right, well, welcome. We have to apologize. There might be some technical difficulties throughout the day. We have been closed for 3 days, so we're scrapping this together. But thank you so much for coming to the University of Texas at Austin School of Architecture. My name is Corey Beeg. I'm the Program Director of Architecture, and this is our symposium, Architecture After AI. I co-chaired this with Clay Odom to my left and Daniel Kohler to my right. They'll each say a few words about the exhibition and the symposium. I just want to welcome you. As I said, the sort of context of this, for those who are watching this later or those who just flew in, Texas just went through a major ice storm for days, and we've actually been closed for 3 days, the school. Today we're functionally closed still. Half the classes are closed and not running, some are running. So really thank you so much for coming today. We do have power and Wi-Fi, so it is a nice space for that. Also, if there's ever been a hint that AI and nature's feelings about AI, well, maybe this is it. We'll see. Hopefully not, but it's certainly a signal. So without further delay, I'll pass it to Daniel Kohler, who will introduce the theme.
The theme, yeah. Good morning, everyone. Architecture after AI. Why after? Like I thought it just started. First, I think after the last frenzy months is a good moment of stock taking. Really more to theorize to think about what will be really the influence on how we learn, teach, practice, build, and so on. Like what will be really the implications. But also I think after, because technologies never have really an impact on architecture. We're always a quite robust discipline. Maybe the invention of drawing itself had an implication, or it might change discipline. Maybe materials, or some materials, did have changed very much the proportions of architecture, like reinforced concrete. But did really digital technology before really changed architecture, the way how we practice it, the way how we see labor? Good question, hopefully. And I think that for everyone actually using for the first time, like a text-to-image prompter or just a chatbot that we have now at hand, is also a very experiential experience. You could say, like, through this experience, you feel that something comes after that. It fundamentally changes you, how you think. Maybe in the future you will create, you will write. Maybe in the same way as when we invented books, with book printing, and so on. So let's see, let's debate that, and that's my architecture after AI.
Thank you, Daniel. And the exhibition that you see, really immersive environment that we tried to create for you all today. The exhibition is an incredible sort of cross-section of the current state of the art in terms of text-to-image AI production. What you see around you is a series of over 2,000 or right at 2,000 unique images submitted by architects, practitioners, designers, professors, theoreticians from around the world. Over 60 different people submitted work for this. And I think what's compelling, or what we're finding compelling about this, is that even though the platform is standardized across these images, what you see are unique takes, unique collaborations between designers and AI, and you see an incredible diversity of output from that. The emerging aesthetics that you can see coming out of this exhibition we think are unique. Some have evolved even since the imagery has been sent to us, and that factor is incredibly powerful. And it's the moment that we can start to set the stage and start to debate what this means and how we can use it moving forward. Thank you all for attending, and we look forward to a great day.
All right, thank you, Clay and Daniel. So the symposium component. Text-to-image AI, as everyone knows, just exploded this summer. It completely changed how the everyday person is working with AI and understands AI. Before that, of course, AI has been around for a long time. We've been using it in very specific ways for very specific tasks with a very kind of specific group of people using it. But that's totally changed over the summer. Now, these tools that were for very specific purposes are becoming more generalized. Graphic designers, industrial designers, artists, architects are all using the same platforms. We're all using a lot of these same tools. And then with ChatGPT, obviously not only designers, but everyone is using this tool. Kids in middle school, professors figuring out what books to use in their research papers are all using the same kind of platform. So that scope of AI has completely changed. So what we want to do today is invite speakers that all work with AI in some way or another in very different ways, but all towards a similar point or a certain similar goal. And the second is that this event in general really connects to a few other events that have already happened, and they include Acadia, for example, where we had a few different panels just a few months ago, the Neural Architecture exhibit at Michigan, the Strange exhibition in Fort Worth that Ryan Manning put on. This is sort of a continuation of this sudden emergence of these exhibitions related to this material, and so we invited people who are from those different exhibitions, but also people who are not, hopefully leading to new trajectories past this one that might open up new exhibitions, new avenues that go beyond where we are right now. The third is that this had to be now. I mean, we're at a singularity in architecture. This is a transformative moment in architecture. It really couldn't delay. So as suddenly as AI came on, so did this exhibition. Really just put together in a few weeks, maybe a month of time. And it comes at a time when architecture is also a crisis. We know it's failing to deal with the environmental issues we have. Of course, we're dealing with them, but not enough. We're not dealing with the systemic problems of our field. Our difficulty in translating technological innovations into mainstream practice. Of course, there's brilliant ideas out there, but none of them, well, not none of them, but a lot of them are not feeding into our everyday architectural firms or the way we build architecture or design architecture. And so hopefully this starts to become an era where we do start to connect these different dots and actually expose these more technical or more isolated things that we're dealing with into the mainstream. Gottfried Simper in Style and Technical Arts wrote that the cyclical nature of art's evolution, within that cyclical nature, when there's periods of decline, there's also a phoenix-like birth of new artistic life arising from the process of its own destruction. So maybe if we're in a moment of crisis in architecture, we're looking at after architecture where we have this new birth and this new thing happening. Finally, in putting these panels together, we selected people who are grappling with questions like architecture in relationship to the environment, in relationship to labor, technological innovations, and hopefully they'll offer a critical voice, but also a hopeful voice as we move forward. So before we introduce the panel, I just want to give a thank you. All of us want to thank Michelle Addington, our dean, for supporting this exhibition. Also, our various faculty and staff who have helped as well. Bridget, Casey, Keith, Cole, Alan, Kelsey, who else am I missing? All the TAs who have helped. Really just an incredible team of people at the School of Architecture who have really helped put this thing together. So thank you very much. All right, with that, I think we'll get started with the first panel. So what we'll do, we have one person online, so we'll zoom them in, and we have two people here. Andrew will start, and then we'll move on to Jenny and then Ed. And let me go ahead and first introduce Andrew, and I'll introduce each panelist before your presentation. So we'll start with Andrew. Andrew Cudlis, let's see, I have this here. So Andrew Cudlis is a designer based in Houston, Texas, where he is the Bill D. Kendall Professor at the University of Houston's Hines College of Architecture and Design, as well as the Director of the Construction, Robotics, and Fabrication Technologies Lab, Craft Lab. In 2004, he founded MATSIS, a design studio exploring the emergent relationships between architecture, engineering, biology, and computation. He holds a Master of Arts in Emergent Technologies and Design from the Architectural Association in London and a Master of Architecture from Tulane University. The work of Matsis has been exhibited internationally and is in the permanent collections of the San Francisco Museum of Modern Art, the Centre Pompidou in Paris, and the Frac Center in New Orleans, France. His work on Confluence Park in San Antonio, here in Texas, has won a number of awards, including a 2019 AIA Honor Award. So welcome, Andrew.
happen. I'm really happy to be here. Just try to zoom things right on top of. Cool. All right. So this talk is partially based on a paper I'm currently working on called Hierarchies of Bias that explores 3 hierarchical layers of operation within generative AI text-to-image platforms and explores possible biases at each level. It moves from the collective level of training data to the computational level of models, weights, and algorithms, to finally the cognitive biases that users may propagate in their own kind of use of these models. So I'll try to touch on all of these topics in the talk today, but I also want to discuss a larger topic that I've been thinking about long before this current wave of AI. So the subtitle of the talk, The Weight of Our Tools, is a reminder that tools are not neutral, but carry with them the burden of the culture in which they were made. All right, so every tool, no matter how primitive, is an artifact of the culture that produced it. As the saying goes, we shape our tools and thereafter they shape us. We are in a state of co-creation with our tools. There's a symbolic weight to our tools that they carry with them value and challenges of the culture in which they were produced, used, and evolved. But one of the challenges that we currently face within our picture is that over the last 30 years, we've developed a rich but incredibly complex ecosystem of design media tools. 30 years ago, I was a freshman learning how to draw with graphite on vellum. And now I'm teaching a freshman class on what I think are the 12 primary forms of media and their associated platforms, formats, and translation protocols. More importantly than this Cambrian explosion of design media is the direction in which it has evolved. With few exceptions, nearly all of our design media tools that have emerged in the last 30 years have focused on production, increased efficiency, and accuracy, and complexity. I would argue that very few tools have focused on expanding our imagination. I think of the current wave of generative AI tools as a welcome difference to the last 30 years of design media tools. From a perspective of the user, they are incredibly easy to learn. I often refer to my use of AI tools as a form of sketching, as that is what it feels like to me as a user. They are fast and inaccurate, like a sketch, but in their gesture, they capture the essential ideas of a project. I think the contrast with the majority of our other tools is important. While tools like Grasshopper or Revit or V-Ray often take months or years to learn, the basics of working with Midjourney or Stable Diffusion can be picked up in hours or days. However, more importantly, the difficult aspect of AI tools are that their cultural weight is so obvious. Although all tools are biased and are mirrors of the culture that made them, these generative AI tools reflect our culture back so clearly that it's often startling and disturbing. So I want to step through the 3 projects that I submitted for this exhibition and discuss some of the most interesting features or bugs that I found helpful in forming my understanding and use of these tools as a designer. The first bias that I want to discuss is a bias towards resolution. And that might sound strange because all of us are probably used to using rendering tools where resolution is simply a factor of changing a number for the camera and waiting longer for the result. But there's no fundamental difference in content when you change the resolution. But these models like Stable Diffusion and Midjourney are trained on images of a very specific resolution and aspect ratio. Asking the model to produce images that don't conform to these parameters can produce surprising results. So I'm showing all of them here, but I'm going to jump through all of them individually. So this, almost all the things that I'm going to be showing you, these very, very simple prompts, often just one or maybe 2 or 3 words. And I'm doing that very explicitly to try to understand kind of what the overall, what is the meaning of that word or those few words, and basically trying to limit the number of variables, let's say. So in this case, I'm using the word machiya, which is a Japanese word for merchant house, traditionally within Kyoto or other kind of urban cities in traditional Japan, that it's basically a townhouse. Often the front of the house would be used to sell wares like kimonos or ceramics, things like that, and the production of that and the storage of it would be at the back of the house with the family living above. So I was using this prompt Machia, and I used, in this case, Stable Diffusion 1.5 with a seed. I kept the seed constant. Not that I don't think it mattered because of the resolution. But if we step through these, at 256 by 256, the prompt completely fails in Stable Diffusion. The image produced has seemingly nothing to do with the Machia typology. And this is because the model is trained on 512 by 512 images. And you can see when I prompt it with that resolution, it produces a fairly accurate depiction of a merchant's house in Japan. I'm sure Japanese architectural historians would quibble with a lot of the details and things like that, but on a surface level, I think it's fairly accurate. At 768 by 768, we still get kind of somewhat of a Machia, but now the focus begins to shift, or drift, I should say, to the larger street. At 1024, we're starting to experience the model's tendency to duplicate information. At 512, any 512 by 512 area within this larger image has some amount of cohesion, but looking at the image as a whole, it doesn't actually make sense. Your eye wanders across the image. If you just look at any one corner, it kind of it's believable as an image, but as a whole, it kind of begins to break down. This continues as we move up at 1280. At 536, even the typology of Machia are gone. We no longer see wood and other kind of features that you would normally think of with Machia. And instead it's replaced with a complex wall of urban form that seems to obsess over red vertical signage. At 792, we only see vague references to space and form. The street is nearly gone. Instead we have signs, trees, and urban form. And finally, at 2048, the street has disappeared entirely, and we are left only with an amalgam of nature, architecture, and advertising. Asking the model to produce something at radically different resolutions can produce results that seemingly reflect larger aspects of the latent space. And I'll come back to this idea in just a moment. Before I do, I want to talk about another bias in relation to some of the, so that bias that I was talking about with aspect ratio and resolution, I'd say is kind of built into the algorithm at the moment. That it's trained on a certain material. It doesn't matter what the training data, it would always kind of fail, let's say, in a similar way. This, though, is more related to the training data. If we return back to, let's say, the native format of 512 by 512 of the training data, the Stable Diffusion model seemed to have an adequate understanding of the Machia typology. However, I was curious if it really understood the word in its native Japanese kanji rather than the English transliteration. Clearly something was off here, as the English prompt was much more accurate than the Japanese prompt. Both of them are producing urban form that you could imagine being in Japan or maybe another Asian city. But the English version seems to be more accurate. So moving between models, so in this case now going from Stable Diffusion 1.5 to Stable Diffusion 2.1, so moving between models can help to understand both the larger issue of why something isn't working and also sometimes the specific tendencies of each model. So you see here 2.1 is actually in some ways doing a better job in the English transliteration, but when given the Japanese kanji, it is, I'd say, failing in a similar way to the previous model. So switching to Midjourney version 4, we see again the English version performing better. That all of them look like traditional Japanese Machia or similar. They have a much more painterly effect, I would say. But when the Japanese prompt is given, we're getting some very, very strange results, like a giant green lizard hovering over one of the houses. And if we take this even further to Midjourney v3, we see that now it's actually the opposite in some ways. The English prompt fails in 3, I'd say, out of the 4 times in a very dramatic way of producing a woman instead of a building. And in the 3rd case, it produces, I would say, not a Machiya typology at all, but just something vaguely Japanese in its architecture. And in this case, the Japanese prompt instead, I would say, is more successful. None of them are producing what I would normally call like a Machiya typology, but they are producing kind of urban form consistently. So like, why is this happening? Number one, a lot of these models are trained on the Lion 5B dataset, which is 5 billion text-image pairs scraped off the internet. Of those 5 billion images, 2.8 billion are with English paired text. So, and then the next most common paired language, I believe, is Russian, with about 250 million images. So it's a wildly biased model, let's say, towards English, number one. So it doesn't really, in this case, when you give it a Japanese word, it doesn't really understand what it means contextually within the Japanese language. Instead, it's breaking it down into its component parts. If you look at the characters there, the first one is town, and the second is house. It means townhouse. So it's producing, it understands the meaning of each individual word or each individual character, but doesn't understand the way to form compound words in the same way that it does in English. So in all of these cases, if you look at the bottom, I'll go back a few slides, all of them are producing houses in towns, but none are producing the specific Machiya. Okay, so the first project that I submitted to the exhibition returns to the issue of resolution. Rather than change the resolution with the same prompt, I would, like I did with the Machiya, I was curious how changing a simple prompt while keeping the same seed in an extreme resolution would tease out the stereotypes that the model has about a variety of cities. I ran the same prompt on the 81 cities that the UN determined had a population of 5 million people or higher as of 2018. Because Stable Diffusion model can be deterministic when using the same seed, unlike Midjourney, which will always give you a different result even with the same seed, you are able to compare the effects of minor changes to the prompt. I selected 10 of these images for the exhibition. The results were shocking to me. Color was the immediate difference. Europe and North America were gray and low saturation, China and Japan were red, South America, Africa, and the rest of Asia were colorful. The prompt was, quote, a street in blank, in X, where X was the name of one of the cities. So we see here a street in Tokyo and a street in Delhi. And because the seed is constant, the overall noise field that is generated at the very beginning, before it knows anything about the prompt or anything like that, is always the same, and then it's refining that noise towards that prompt. So you tend to get images that look very similar to each other, and you can begin to understand what the primary difference is, or what the primary meaning, let's say, at least what the model thinks the meaning is of that difference. So I'm just going to cycle through these fairly quickly. I just picked out basically 2 in North America, 2 in South America or Latin America, and so on and so forth, to get 5 different regions of the world covered. So a street in Mexico City, a street in Cairo, a street in New York, a street in Lagos, a street in Rio de Janeiro, and a street in Los Angeles. A street in London, and finally a street in Barcelona. So those were the 10 images that I submitted to the exhibition, but I want to go back to the image of Delhi, because I kind of lied a little bit. I told you that the prompt was a street in Delhi, but when I first produced, I ran a script that went through all 81 images, and it was a street in X for all of those. But when I ran that, this pattern started to appear that during that initial run, any city that basically wasn't in North America, Europe, China, or Japan would produce results that were stereotypes of the developing world. Although we are used to prompting with what we want, negative prompting, or telling the model what we don't want, can have a significant impact on the resulting image. Without the negative prompt, the model assumed that any street in the global south was made of rags and garbage. So that was the original image, and then same seed, but just adding the negative prompt poverty, basically telling the model, don't show me poverty, produced the image of Delhi on the right. And I'm showing it to you now, but I just couldn't submit all of those images to the exhibition because it was just such a clear kind of form of bias that kind of anything outside of China, Japan, Europe, and North America were essentially these cities made of rags and garbage. It also assumed that the only difference between the 18 Chinese cities with populations over 5 million was the quantity and shape of their red lanterns. I don't think we can ever rule out all of the biases of these models, but I think moving towards a more diverse training set that isn't just a scrape of the internet would be a good start. The internet is heavily biased towards Western media and the English language specifically. Although I think this has helped make amazing progress in the last couple of years in these large language models, not only is the internet a biased source, it's also mostly full of garbage data. The second project I submitted to the exhibition focuses on a different type of bias that I think is a result of both the training data and the weights placed on the model by the programmers. All of the text-image generators use some version of CLIP, or contrastive language image pre-training. This is used to help guide the image during its generation towards the user's prompt. It can be thought of as the opposite of the text-to-image generators that we're used to, as it is an image-to-text generator. That it looks at an image and then tries to extract the tokens or elements of the prompt that might describe that image. Using the CLIP interrogator, I entered an image of Confluence Park by the photographer Casey Dunn. After weeks of trying to write the perfect prompt to produce our design, I was curious what CLIP saw in the image. Let's see if I can read this. I can barely read it. Let's see if we can make it bigger here. A group of people riding bikes under a canopy, digital rendering by someone named Matteo Perez. Featured on CG Society, concrete art, natural botanical gardens, Gardena architecture, the narthex, rendered in Redshift, stone pews, Napa, interconnected human life forms, Sufism. All right, so I'm going to step through these, and I'm not going to read the rest of them because they just get crazier and crazier. But essentially, I played a game of telephone or rumors, goes by lots of different names, where I would take I took the original image of Confluence Park, plugged it into CLIP, took that text, plugged it into Stable Diffusion to create an image, and then plug that image back into CLIP Interrogator. And I did this 10 times. To see kind of how much of the original architectural intent had remained at the end, in the same way that you as a kid, play the telephone game. So, at first I'd say it didn't do that bad of a job, right? There are these large concrete arching structures with a lot of vegetation and people. If I back up, that's not too far off. You can definitely see, though, that certain things are being accentuated. There's only one bicyclist in this image. There's one tree in one corner and a few trees in the far background. But the vegetation is taking over. The bicyclists are becoming more numerous. Slowly, the vegetation and the concrete turns into tentacles, which just get kind of more and more gross. Eventually, it starts to take on a little bit more of an illustration, where now it's even more tentacle-like, but it appears more drawn, I would say, and even more so now. And after 10 images, we are left with some sort of anime collage of bicycles, teenagers, and vegetation. Which, I don't know, maybe is actually a good description of Confluence Park. As far as like the average user, that might be what it is. Anyway. Just as a way to see if this was just something happening in Stable Diffusion 1.5, I went ahead and tried it, the same exact image that you can see on the far left there, in Stable Diffusion 2.1, Midjourney, and both versions of Midjourney. So using the same initial image, I performed the same game with the 4 primary models that I typically use. In all cases, the final image is pretty far away from the source. Each model has its own tendency, but all of them drop what they don't know quite quickly and drift towards either stock images, in the case of, I'd say, Stable Diffusion 2.1, a colorless mess, Midjourney version 3, or pop culture, Stable Diffusion 1.5 and Midjourney 4. So within 3 or 4 generations, you can see in all cases the architecture is essentially lost. So this is probably the most challenging image of all of them. So it's important to realize that these models are always trying to please you and produce an image. Unlike Google search that will tell you when it can't find any results for your prompt, Stable Diffusion, and especially Midjourney, will always attempt to produce an image, even when the prompt is meaningless. As a quick experiment inspired by Chigozie, Kyle, how do you pronounce your last name? Indri. Thank you. Who was an artist using these tools and now still is an artist using these tools, but is now works for Stable Diffusion for stability. She produced a Twitter bot that called Every Prompt Bot that essentially sends a random phrase to a model and then sends back an image. So based on, I was inspired by her Every Twitter bot. I fed random prompts to Midjourney. Unlike Stable Diffusion, that will convert any random prompt into a random image, Midjourney has the unfortunate ability to nearly always convert meaningless prompts into young, white, steampunk women. I don't know why this happens, but all I can assume is that without a meaningful prompt, it just heads towards the global average of the latent space. Since Midjourney feeds users' prompts and images back into its own model, there's a feedback loop that exaggerates and intensifies the desires of its users. Interestingly, if you attempt to remove the male gaze through negative prompting of girl, woman, and portrait, we are left with the adolescent male gaze, steampunk sea creature, the abyss. All right, so finally, I want to end on a more positive note and discuss my third submission to the exhibition. I also want to return to the issue I brought up at the beginning about these tools being focused on an expansion of the imagination. As we sketch with a pencil or pen, we don't care about accuracy or cohesion. Lines trail off into nothingness, vanishing lines don't quite match up. We forgo cohesion for the speed of a tool that can keep up with our imagination. An individual sketch is almost worthless in the design process. It is an iterative accumulation of sketches that tease out ideas from our imagination that provide value. Last summer, I began sketching an idea for a house to be located outside of Austin in Dripping Springs. Using Midjourney at first, I explored various ideas related to a fabric-clad structure that breathes with the wind. These sketches are not a full design in the same way that a pencil sketch isn't. They are explorations of the latent space of the design that exists in our own neural network. Through sketching, we make connections between memories and visions. I've resisted the urge to start the typical design process of trying to convert these images into 2D drawings or 3D models. I'm not ready yet for that in my process. More recently, I've been using the extreme resolution bug or feature that I discussed before in Stable Diffusion to produce intentionally incoherent images. There's a drive in the world of machine learning to lower the FID scores of generated images. So this score is a measure between the distance between a real image and a generated image, with low scores signifying the ability of a model to produce realistic imagery. So this is something that is seen as a benchmark within the industry that everyone's trying to chip away at getting a lower FID score. I think as designers, we need to resist this desire. We have rendering engines that can produce accurate depictions of our desired realities. I think the value of generative AI images is in their ability to produce ambiguity and incoherent assemblages of form and atmosphere. I produce these images as a way to understand and visualize the latent space of my idea. They don't have to match reality, as my ideas don't match reality yet either. In addition, I have also begun to intentionally forcing Stable Diffusion to produce glitches by using prompt weights that seem to break its desire for coherence. The images capture details for me that I want to see in the design of the house, in its relationship with the landscape. I try never to use references to architects, artists, or styles, and instead use very simple prompts describing what I want to see, weighted with how much I want to see it. I then begin to bring these images back towards reality by using image-to-image prompts or blends. By starting from an initial image or images, the model can achieve much more than the most complex text prompt. I'm able to pull in images that extend across the span of the project, or sometimes even images from previous projects, to help me combine my memories and extend my imagination. I'm sure neither of these images are the final design of the house, but that's not my goal. After 30 years of unrelenting logics of CAD drawings, parametric models, and complex render settings, I'm thankful for a tool that is easy to use and allows me to explore in a new way. At the same time, it comes with the heavy weight of the collective, computational, and cognitive biases that I've discussed today. However, I'd rather face these difficult reflections of our larger culture than look away. Thank you.
Thank you, Andrew. All right, thank you, Andrew. So our next presenter is Jenny Sabin. Jenny is an architectural designer whose work is at the forefront of a new direction for 21st century architectural practice, one that investigates the intersections of architecture and science and applies insights and theories from biology and mathematics to the design of responsive material structures and ecological spatial interventions for diverse audiences. Sabin is the Arthur L. and Isabel B. Weisenberger Professor in Architecture, Art, and Architecture, and the inaugural chair for the new multi-college Department of Design Tech at the Cornell College of Architecture, Art, and Planning, where she established a new advanced research degree in matter design computation. She is principal of Jenny Sabin Studio, an experimental architectural design studio based in Ithaca, and director of the Sabin Design Lab at Cornell AAP. Her book, Lab Studio Design Research Between Architecture and Biology, co-authored with Peter Lloyd Jones, 2017. In that same year, Sabin won MoMA and PS1's Young Architects Program with her submission, Lumen. Please welcome Jenny Sabin.
All right. Thank you all, especially to the University of Texas at Austin for hosting this excellent symposium today, and to Corey Bieg and colleagues for the kind invitation. In my short talk today, I argue that technology, and specifically artificial intelligence, is fundamentally human, and that while generative AI opens new possibilities for the creative process and uncanny forms of ornament and beautifully complex formal structures, architecture has yet to tap into the full potential of AI to generate adaptive and personalized architecture. At the same time, AI has the potential to radically change existing workflows within architectural design, both pedagogically and in practice. For example, computer vision and machine learning algorithms can be used to analyze any mistakes made during construction and improvise solutions. Through the design, steering, and crafting of big data sets, AI can offer new approaches to sustainable cities and architecture to build smarter and to generate empathetic and healing architecture. Through reciprocal engagement with our own changing dynamic biodata sets, facial expressions, and voice tones. Used opportunistically, inappropriately, maliciously, or even illegally, AI presents deeply problematic and ethical concerns around bias, privacy, and entanglements with capitalistic power structures and big tech. These data present new forms of value that we are only just beginning to comprehend and understand, as highlighted in your excellent talk, Andrew. Value structures that are driven towards capturing, manipulating, and using personal data sets for profit, from the stealing and plagiarizing of individual artistic styles and creative innovation to the strategic profiling of individuals through facial pattern recognition. AI is and will continue to have grave consequences. Lost my screen here.
share.
Sorry, everyone.
Sure.
Okay.
This should be planned, but it doesn't matter. So this crowd is now very familiar with Ahmed Mustaq, the founder and chief executive of the startup Stability AI and their product Stable Diffusion, and hero to many for releasing Stable Diffusion as open source. But as Kevin Roos, a technology columnist for the New York Times, wrote in reaction to this release in his article, A Coming Out Party for Generative AI, Silicon Valley's New Craze in late October of 2022, he states, quote, "If this all sounds eerily familiar, it's because Mr. Mustaq's pitch echoes the utopian dreams of an earlier generation of tech founders like Mark Zuckerberg of Facebook and Jack Dorsey of Twitter. Those men also raced to put powerful new technology into the hands of billions of people, barely pausing to consider what harm might result," end quote. While the libertarian ethos and optimism towards the democratization of AI tools through open access should be celebrated, it is groundbreaking and incredibly exciting to say the least. We cannot afford to be naive, or we are at risk of perpetuating entanglements of systemic misinformation, AI-generated propaganda, new forms of plagiarism, and persistent issues impacting diversity, equity, and inclusion. Many of these topics were discussed and debated during the 2020, 2021, and 2022 Acadia conferences. Take, for example, theorist and historian Amelia Jones, who underscores how neutrality is a problematic concept in design, and that the whiteness of tech and algorithm design, including AI, can perpetuate systemic racism and sexism, as it frequently does not prioritize diverse users. She challenges us to consider how design can be driven by issues of access, inclusivity, and equity. To do this, she argues that we need relational design strategies that foreground relationality and participation, and to engage and acknowledge the embodiment of the receiver, and to refuse the neutrality that has dominated art and design in the global north. Instead, she argues we must embrace connectedness and the engagement of broader communities. She offers some explicit methodologies for doing so, including cybernetics and generative strategies that are imbued with feedback loops, where the user and interaction are part of the design process. Philosopher Benjamin Bratton argues that AI is used for both smart and stupid things, and its ultimate purposes may be largely undiscovered. Further, Bratton underscores the presence of what he calls a sensing layer, and its promise to act back upon and govern itself. He highlights how the pandemic highlighted many failed areas within this sensing area. For example, to be excluded from testing and therefore being excluded from being sensed is to not count, which equals exclusion. The data sets driving text-to-image generative AI largely privilege a Western paradigm of new image making. Consider the work of Dory Tunstall, the first Black dean of a design school, who challenges us to decolonize design through the development of a better underlining consciousness with technology, and her question, what does it mean to bring an indigenous consciousness to technology? Tunstall argues that the values of design and tech have been and are still largely colonial, white supremacist, and patriarchal. AI is radically changing the creative arts and design landscape, and in many ways, design and technology have never been more important. A beleaguered planet recovering from the depths of a pandemic and facing an urgent climate emergency demands that design and technology integrate to cultivate new collaborative models and transformative, highly creative applications to comprehend key social, environmental, and technological issues. Recent advances in computation, visualization, material intelligence, and fabrication technologies have begun to alter fundamentally how we design, construct, and make from the nano to macro scales. For example, how might we rethink building materials through 3D printing and biologically informed design? Can buildings be made more responsive through the integration of artificial intelligence and big data? We are in the midst of what some people call the fourth industrial revolution, a paradigm shift that some historians write is the biggest to impact design and architecture since the medieval period. These new intersections between the digital, the physical, and the biological are radically altering the world across scales. And in the not-so-distant future, materials will not just be elements of things and buildings. They will generate immersive spaces. Like the cells in our bodies, sensors and imagers will learn and adapt, making materials not only smart, but also aware, sensing, and beautiful. To address these pressing issues in our built and natural environments, designers and architects must embrace change and cultivate new design models to comprehend these key social, environmental, and technological imperatives. Radical new models are needed for design research, alternative forms of practice, architectural pedagogy, and collaboration across disciplines, industry, and practice. One approach entails the hybridization of labs and studios to fuse innovations across science, technology, and design. Our work in AI stems from this fundamental foundation. We embrace transdisciplinary design with a focus on problem and knowledge generation over immediate problem solving through collaborative design research processes that are emergent, transforming, and evolving for innovative applications across disciplines and disciplinary frameworks. Specifically, our work in AI has focused on the following two questions, one of which I just posed. How might we design and enhance architecture with the bioarchitecture and behavior of our own bodies and local environments? And can building materials be made more responsive through the integration of AI and big data? I'm going to talk about one specific project which builds upon over a decade of work integrating advanced digital processes in textile engineering and fabrication, specifically working with digital knitting processes and responsive and high-tech materials that engage with changes in color, translucency, and light and energy, starting with a commission that came to me through Nike, which was titled the My Thread Pavilion in 2012 as part of the launch of their new technology, which is all familiar to you, called the Flyknit. And jumping scale with Lumen in 2017 as part of the Young Architects program, where we were able to push these technologies and concepts to an altogether advanced urban scale and really look at the promise of how these spaces could transform and adapt over time during the day and through the night. Our collaborative work also includes a significant human component, both in how it is made through a hybrid of analog and digital design processes and through the active engagement with diverse communities in architectural and urban contexts. Why are the concepts and arguments of self-generation and AI plus algorithmic design processes important to architecture and design now? Collaborations across biology, computer science, medicine, material science, and bioengineering afford new modes of thought and design principles that prepare the architect and designer for a paradigm shift that is no longer anthropocentric, but rather transdisciplinary and trans-individual. Importantly, this shift gives rise to a radical new model for pedagogy, research, and practice in a time of environmental and socio-political crisis, the result of our deeply entrenched misconceptions of human dominance over nature, where technology and big data impact important questions of access, well-being, and agency. As just mentioned, our working definition of transdisciplinary is not focused on problem solving, but instead embraces problem generation. Ada, a project by Jenny Saban Studio in collaboration with Microsoft Research, co-evolved in such a transdisciplinary context. In this context, it is possible to produce collective and democratic solutions to these important questions. Ada, with Microsoft Research, explores this possibility space. In conjunction with this work, we are exploring how AI can personalize rooms and buildings. The spaces and environments that people inhabit influence how they feel and how they act. Working with researchers and engineers at MSR, ADA is driven by individual and collective sentiment data collected and housed within the Microsoft Research Building 99 on their campus in Redmond, Washington. The design of ADA commenced with a series of collaborative conversations with my collaborators at MSR on topics spanning AI, adaptive and embedded architecture, affective computing, and personalized space. This project commenced in 2018 and well before the explosion of generative AI just this past year. Named after the polymath, mathematician, first computer programmer, and early innovator in the computer age, Ada Lovelace, this collaborative project embodies performance, material innovation, and human-centered adaptive architecture and emerging technologies. We hoped that through the integration of responsive materials and this emerging tech, that the project could have the capacity to promote and increase well-being and healthier environments as a demonstrator pavilion through people's direct engagement with its architecture. The lightweight pavilion is composed of responsive and data-driven tubular and cellular components held in continuous tension by a 3D printed semi-rigid exoskeleton. An external environmental shell structure assembled from a compressive network of 895 unique 3D printed nylon nodes and fiberglass rods holds Ada's form in continuous tension. The lighting system and materials of the cyber-physical architecture respond to human participation. As individual and collective facial pattern data are collected in real time through a network of cameras processed by AI algorithms and transmitted as sentiment through light and color. Ada's brain ring is a bespoke yet simple assembly of laser-cut stainless steel parts with strategic voids for ventilation and channels for wiring. It accommodates all of the electronics and networking hardware used to process, display, and spatialize expression as material read from an on-site PC. It discretizes that data into streams depending on spatial contextual conditions. The brain ring, as can be seen from above, contains Raspberry Pi 3B plus microcontrollers, custom PCBs for pulse width modulation, addressable LED control, Ubiquiti 10x Ethernet switches, power supplies, and Ethernet power cables. Working collaboratively with Microsoft Research, we designed and programmed the software architecture for 2 programs which allow Ada to interface with human sentiment in her environment. A program running on the on-site PC and a program running on each of the Raspberry Pis in the brain ring. The PC software continually queries data from the network of MSR cameras that analyze user facial expressions. These expressions are classified using Microsoft researcher Daniel McDuff's platform, which drives Ada. McDuff works at the intersection of psychology and computer science to design hardware and algorithms for sensing human behavior at scale to build technologies to improve human experience in daily life. AI algorithms turn these data into numeric gradients of sentiment and are passed to the PC in the form of probabilities, each representing the program's certainty that a given expression is being observed. Expression data is cross-referenced by the programs to check for patterns such as 1, global average of all sentiment values, 2, local averages of sentiment in close physical spatial proximity within Ada's site, 3, sentiment values with global maximum probability, and 4, sentiment values with local maximum probability in close physical spatial proximity within Ada's site. A table of color values represented as 3 component vectors was designed to correspond to real-world facial expressions and voice tones. Color vector transformations are applied through a series of functions which augment or interrelate the spatial zones just mentioned. Finally, color vectors are transmitted to their respective spatial zones on Ada's exoskeleton and knit structure through a local network connecting Raspberry Pis to the external PC and through a PC DMX interface to Elation 6-par lights. When data is received, the program instantiates a specified number of LED pixel objects, passing a color vector to each one as its color attribute. The pixels are illuminated through a series of animation frames, which update each pixel's color attribute. Finally, the animation occurs at an interval of 3 seconds with 100 frames per second, and in turn, the responsive high-tech fibers that compose the digitally knit surface and fiber optic skin of the central tensegrity cone respond and change in real time, reflecting sentiment back as material, form, space, and light. An important aim of the project is to expand and inspire architectural engagement with humans. While AI powers the project through the precise narrowing and statistical averaging of data collected from individual and collective facial patterns and voice tones, the architecture of Ada augments emotion through aesthetic experience, thereby opening the range of possible human emotional engagement as a continuous, human-driven, and AI-powered generative process. In turn, the project opens new pathways for fundamental research on the use of AI to correlate connections between human sentiment and local environment. And Ada continues to be used as a platform for research by researchers at Microsoft Research. Personalized architecture, in this sense, may sense subtle changes in human emotion through sensors and interfaces that detect changes in facial patterns and voice tones, and respond in ways that increase well-being and hopefully promote healthier environments. Unlike the pioneering work of Mark Sager, such as his Baby X project, which seeks to humanize AI through, quote, more symbiotic relationships between humans and machines, end quote, Ada does not appear lifelike. Ada offers subtle and abstract interactions with humans through space, material, and form to augment and expand our emotional range in a specific context, in this case an office environment, which in turn affects the probable sentiment data being collected as new information. The spaces and environments that we inhabit influence and partially shape who we are and how we are feeling. Through the integration of both responsive materials and AI, Ada hopefully offers an interface for personalizing architecture, or at the very least opens new questions to make it more human and reflexive. At the same time, Ada expands human emotional engagement through beauty and materiality. Ada hopefully has the capacity to promote and increase well-being through direct engagement with the architecture that we inhabit and encounter. In this sense, biosynthetic architecture is not a metaphor, it is an analog of deeper connections, a trans-individual and transdisciplinary architecture that is steered by the systemic and relational conditions of life, as an undulating network of parts and their informed wholes towards empathetic, healing, and adaptive architectures. In my lab, we have been leveraging the context-driven processes of biological systems with AI and other advanced technologies to design and fabricate material and spatial structures that don't simply mimic nature, but integrate the dynamics and specificity of material and environmental feedback and human engagement. This approach hopefully enhances both technical and conceptual understandings of nature's inner workings for the design and fabrication of bio-inspired material systems, and a possible model for new adaptive architectures. So with that, thank you. I've highlighted one project, and this is where you can find us. I'm really fortunate to be able to collaborate with some amazing industry partners, as well as receive incredible funding from the NSF and beyond. So thanks so much.
Okay, we're just going to share Jenny's video real quick so you can see. Imagine Jenny talking over this. Is there sound?
There is sound.
There is sound, okay. Had to throw sound.
Ada is driven by artificial intelligence. It's a project that smiles back at you. The name comes from Ada Lovelace, one of the first computer programmers, and the linkages between weaving and computation. Knitting is one of the earliest examples of 3D printing, additively layering link by link, row by row material. The project features soft forms that are more feminine versus masculine, and that's the paradigm shift in architecture. The shape of Ada is an ellipsoid, and it features a unique exoskeleton composed of a network of fiberglass rods and 3D printed nodes. Every single node is different and has a unique ID attached to it. The interior surface is composed of hundreds of digitally knit cones and cells in a network of webbing. In the center of Ada is a large integrity cone composed of a skin of fiber optic cables. Photoluminescent fiber absorbs energy from the lighting and then emits that back as knitted light, as glowing light. But the real magic comes through how people actually make it. On the interior soft surface is a whole network of LEDs connected to a network of cameras within the atrium, reading the facial expressions of people in an anonymous way. When Building 99 is very active, the project will be very vibrant and highly transformative. There are moments where it blushes. The hope is that people realize their engagement is actually driving the project, that the project begins to gain its own life in the way that it is interacting with people.
Thank you, Jenny. All right, bear with me for 1 second while we get Ed on. Okay, Ed, so if you want to share your screen, to go here. Yes. Hold on 1 second. Okay. All right, give me a test. All right, looks good on our end. Can you say something?
Check.
All right, one more time.
Check. Testing.
Perfect, we're good. Ed, all right, let me read your bio. All right, so our third speaker of the morning is Ed Keller. Ed is one of the two who weren't able to make it, but we're really glad to have you here in this format. It's wonderful. Ed Keller is a designer, professor, writer, and musician, and with Carla Litau is a co-founder of Spec AE and owns Studio Design Research and Architecture. He has taught architecture, film, and technology since 1996 at many universities and lectured and exhibited internationally. His research and practice explores the structures of feeling which link cultural, infrastructural, ecological, and technosocial systems, revealing emergent terrestrial and cosmopolitan potential. With Leitao, Ed co-directs the Post-Planetary Universal Design Program at the New Center. He's an affiliate researcher with the Antikythera program led by Benjamin Bratton. He is creative director of Singularity Net, and in 2021-22 was a creative director with the Italian Virtual Pavilion Venice Architectural Biennale. As a guitarist, improviser, composer, he has released 8 solo guitar recordings since 2018. And for 42 years, Ed has been an avid rock climber. Please welcome Ed.
Thank you so much for your patience with me coming in virtually today. Many thanks to Texas and to Corey and Clay and Daniel and all the organizers and the other participants. It's a tremendous honor to join you. Today, the talk that I'll give is about a 30-minute talk, which is a development of an earlier keynote I gave at the AGI 22 conference last summer. This has got a lot of new material in it, and I think it'll be, I hope, provocative and interesting for everyone today. You'll be familiar with all the tools that I've been using. I've been working with Dream Studio, various models of stable diffusion, VQGAN, ArtBreeder, and Wombo. Everyone, I think, here is deeply embedded in this stuff. So I'd like to begin by casting a very wide net to try to map what seem to be the opportunities presented in our current work with machine learning and AI, and talk a bit about what the consequences might be. The talk is a little bit rhapsodic, a little bit personal, and again, hopefully some of the provocations will be useful, and maybe a few will be novel. This is an outline of the talk. I want to touch on a few of these themes and use them to structure what I'll present. I'll begin with an overview, kind of children's story beginnings. I'll talk about cognition everywhere. I'll try to touch on language and meta-language, latent space in the context of prompt engineering. I'll spend some time with the cosmo and geopolitics of the multiverse and machine learning and artificial intelligence and AGI generally. And then I'll finish with another children's story that tries to address the question of the ultra-conserved gesture. What is the overview effect? Well, the children's story I'll show now has to do with the famed overview effect, what it means to see Earth from space. But what if we transpose that and ask, what does the AI see when it looks at human life? What's the perspective of AI? I'm also interested in beginnings, foundational beginnings, aeon and arche. I'm interested in hyperbolic space. And I'll read a quote from the philosopher Michel Serres as I show some of these images. Nothing distinguishes me ontologically from a crystal, a plant, an animal, or the order of the world. We are drifting together toward the noise and the black depths of the universe. Our diverse systemic complexions are flowing up the entropic stream toward the solar origin, itself adrift. I think here of initial formalisms, of course, of the emergence of life. Knowledge is at most the reversal of drifting, that strange conversion of times, always paid for by additional drift. So let's ask, where does thinking happen? And what's the relation between symbolic or metasymbolic or subsymbolic systems and levels of sapience, thought that can think itself? And how does our current work with machine learning and AI connect to a deeper ecosystem or an architectural or urban thinking of systems intelligence? It strikes me that we're entering a very interesting time, a wild time, where calendrical heresies from science fiction find their way effortlessly to our everyday world. For example, isn't a structure of feeling a deeply formal yet undefinable belief system that's writ in the space between fantasy and real-world systems? It's governing machines and tools and weapons, instruments and landscapes that are all moved by those belief systems. So there are mathematical and formal and logical systems that underwrite nearly all the infrastructure we live in today. And they're increasingly subject to inflection from formal systems, from machine learning and artificial intelligence that subscribe to completely different ontologies of being and action. Perhaps for the first time in history, infrastructures and frozen and slow capital will be sensitive and responsive to those alternate belief systems. We saw a beautiful example of that in the work that Jenny just showed. I also think here of Stephen Jay Gould's meditation on the Cambrian explosion, and Andrew mentioned the Cambrian explosion of technology that we're going through right now. Werner Vinci has noted that it took many millions of years for the Cambrian explosion, of course, but we're living through this little hiccup in a few decades. The seizure, the jackpot, as William Gibson calls it, or the singularity. So where do we situate ourselves when we try to come to grips with the metamorphosis of human creativity and sapience in the midst of this explosion of machine intelligence? This sea change, like all of you in the past few months, I've created, working with machine learning and AI, more work than literally 30 years of designing. In just minutes, each of us has access to a large percent of human history's creativity, indeed, with all of the biases baked into the models, as Andrew and Jenny pointed out. So working with these tools, we see unfolding in real time a set of permutations of art, design, and reality that could have been, that wasn't, that may be, and might be coming. And to the overall machine learning and AI imaging project, all the images we're making are interesting because they're all useful data points in a cataloging and labeling process. All the companies and organizations are harvesting the ways that we compose poetry. They save our prompts. They cross-correlate the images that the prompts have produced. It's monetization all the way down, just as Thomas Pynchon might have humorously observed. If you and I can lazily produce decades worth of work in a few months, and these tools are available to everyone, then what is the kind of singularity moment that we're encountering right now? And for architecture, because architecture, of course, three-dimensional design, and very soon composable, structurally analyzable 3D content will be produced in the same kind of process. What happens to cognition itself? My older son, Hart, mentioned recently that he thought in just a few years AI systems would write, generate, animate, edit, and produce entire feature films, which would be better than any human film that's ever been made. And they'll be seen by no one, because so many films will be made like that. They'll just be made and lost or never seen, like tears in the rain, the debris accumulating at the feet of the angel of history as she is blown backwards into the future. And of course, the elephant in this room right now is the singularity. This is precisely why for more than a decade I've been arguing that we need to look to models of speaking with the alien, drawing from philosophy, science fiction, linguistics, Medi and SETI, because what we're entering right now is a time where all reality is driven by emerging and totally non-human ontologies and epistemologies. And our only recourse can be a cosmopolitical gesture towards those non-human alien minds and agencies. It is a real singularity. We have no idea what kinds of engineered cognition are waiting for us past that threshold. We began as mineral. We emerged into plant life and into the animal state, and then into being human, and always we've forgotten our former states, except in early spring, when we slightly recall being green again. That's Rumi. You're a life with its immensity and fear, so that now bounded, now immeasurable. It is alternately stone in you and star, and that's Rilke. So what does it mean to link the work that we're all doing, machine learning and AI collaborations, to a kind of transhuman deep ecological thinking that could be informed by Rumi and Rilke or by Aldo Leopold's Sand County Almanac? In such a case, the modes of communication being tested by humans in the loop with AI would be loosely analogous to creatures in the loop with real ecosystems. So the work I've been doing for the past year has been a critically intuition-driven approach to synthesize feelings of impending loss, love, cosmologically scaled archetypal experience, and driving that through the sea change of collaboration with AI that we're all undergoing right now. In a very classical sense, this is a kind of a possible reconciliation of reality and a wildly proliferating ecology of ontologies. The reality that the machine learning elves and the algorithms we're working with in the young AI, the reality they perceive as orthogonal to our reality, it's only partly connected. But at the same time, the reality which results after this encounter, this moment we're living through, will be a hybrid between what we knew and something quite different. Remember, not many creatures made it through the Cambrian explosion. This could resonate with Eva Jablonka's idea of a kind of minimal consciousness that was necessary for creatures to survive the Cambrian explosion. This was a factor contributing to their survival. In the shortest timeline, though, right now for me, over the next few years, the interest would be to continue critically intuitive development of space, image, and sound. We're kind of in this moment Wim Wenders showed us in his film Until the End of the World. We're all in this kind of boat, as my friend Harry Hall once wrote. You're sitting at a table next to a window, gazing into a plane of light, trees and wind outside, not breaking your stare. We're hypnotized. I recently had a conversation with ChatGPT. I was asking it about its opinions on pocket universes and hyperbolic space and music. And ChatGPT agreed with me that it is certainly possible to consider the concept of hyperbolic space and geometry in relation to music. It said, in particular, the idea of a hyperbolic space in which the curvature of space is negative could be relevant to the concept of expanding or contracting musical structures, which I loved, thinking as an architect. It said, for example, a piece of music could be composed in such a way that certain musical elements or motifs are repeated and expanded upon over time, much as I do in my own improvisational work in the guitar recordings I've made. And ChatGPT said this would create a sense of complexity, similar to the way that a hyperbolic space can have an infinite number of layers or dimensions. Now, this is a bit of a poetic image, of course, for you, but it's also a technical problem, the embedding of all of those layers and dimensions, which is exactly what's happening as we work with machine learning and AI. So who are we communicating with? Who's communicating? Who's talking to who? Who's sending messages to who? Humans in the loop. Our planet has been indexically communicating with itself and thinking for billions of years. The Earth has registers of massive addressability in the river meanders, for example. This very beautiful and famous image from the Army Corps of Engineers of the Mississippi River meanders. Millions of years of exploration of phase space. In her foreword to Kavia's recent book, Logiciel, the philosopher Anna Longo talks about a Ted Chiang short story titled Exhalation. In this short story, alien researchers belong to a peculiar race of mechanical thinking beings who inhabit a world, the inner nature of which will be revealed by arriving at a full understanding of the functioning of the brain. This sounds awfully like what we're doing right now, right? Using a complex self-observation device, the scientist introduces a microscope mounted on a miniature arm into the exposed back of his own head. This is what certain neurosurgeons have done, actually. While pushing aside the golden leaves packed into the cognitive engine, that's a little bit different than our brain, the scientist, he manages to observe from within the activity that he is conducting in the act of studying his own brain. He sees memories encoded on tiny plates continuously moved by currents of air, and he comes to understand that the instructions to release air are provided by the syntax of the written reminiscences. So there's a feedback loop there. My consciousness could be said to be encoded in the position of these tiny leaves, but it would be more accurate to say that it was encoded in the ever-shifting pattern of air driving these leaves. So those feedback loops, that alien computational platform, seems so different from us. And yet, if we make a skill shift to the city, to what we do as architects, as urban designers, as theorists, as historians, and if we ask the question, where does this model of cognition and computation might already be operative? Think of Venice and what Ruskin said about Venice, saying in Stones of Venice, quote, the glacier stream of the Lombards and the following one of the Normans left their erratic blocks wherever they had flowed, but the lava stream of the Arab, even after it had ceased to flow, warmed the whole of the northern air, and the history of Gothic architecture is the history of the refinement and spiritualization of northern work under the Arab influence. So Ruskin was seeing cultural flows across 500, 700 years as geological processes of a kind of proto-thing. All of this, I hope, is making you laugh a little bit. It makes me laugh. I think of a passage from Borges. Foucault also laughed at the beginning of his book Order of Things when he was recalling a different passage from Borges, but they're both related to classification, language, and ontologies. So in Funes, Borges said, quote, Locke in the 17th century postulated and rejected an impossible language in which each individual thing, each stone, each bird, and each branch would have its own name Funes once projected an analogous language, but discarded it because it seemed too general to him, too ambiguous. A world in which there are no general names, there are only specific names for everything. And so we can approach the problem of language and ontology and translation not only looking at relations between humans and AI, but also human to human, human to non-human, human to alien even, since broadly speaking, translatability, labeling, annotation constitutes a set of universal system-to-system information and energy flows. Again, I hope that you're all chuckling a little bit. We've got to keep our sense of humor going here. When we ask who's communicating with whom, human in the loop and on the loop, what's going to happen in the next few years? This I thought was a brilliant tweet from a few months ago, thinking about Midjourney and how kids will be talking in just a few years using prompts. I imagine Andrew and everyone, you've either seen it or you just laughed a little bit. And so when we look at current implementations of image generation software such as Midjourney, we see a combination of AI image software with a social platform that makes text prompts immediately accessible to other users, thousands, hundreds of thousands of users by default. And so in a way, we see the real-time unfolding of a form of proto-cognition. And it's also very savvy from a business point of view and from a platform design point of view. If we think about this and we think about latent space and prompt engineering, and we rewind more than a decade to Lev Manovich's work, when he and his team were analyzing more than 1 million pages of Japanese manga comics. And we can ask the question, what's the latent space there and where was meaning constituted? And it's worth noting that Lev, of course, is doing some very beautiful work right now using Midjourney and other platforms. So Lev is deeply embedded in this process as well. But latent space. What is the change that's happened in the past decade in terms of our relationship to latent space and analysis? Midjourney prompts are generally available, and this little project basically scrapes 250,000 image-to-text pairs to do an analysis of them. This is available to any user, at least in terms of the public prompts. And Midjourney, of course, is very alert to this factor. David Holtz, founder of Midjourney, co-founder of Midjourney, said in an interview in the Register a few months ago, the social aspect of Midjourney recently began enhancing image quality. Holtz saying that company engineers introducing version 3, which for the first time incorporated feedback loops based on user activity and response. Well, Andrew, you've been keenly aware of this, and many other people working in this space, I'm thinking of Matthias as well. If we look at some of the work that architects using these tools are doing, we see a sophistication in prompt engineering and a critical assessment of how the prompts work within the rule set of the systems, but how they also tie out to the broader platform and meta-platform design thinking. The AI intelligence as per tokenization of words, of concepts, and Andrew, you just did a very beautiful talk about some of these themes. Matthias made a comment a few months ago that I thought was very important also. This is a comment in relationship to how AI perceives emphasis and gesture in our prompts. And it was a hint for me to link to this question of what it means to think about ultra-conserved gesture. Matthias pointed out, talking about a prompt, that this was where it became interesting to him, as some of the commands translate how we speak about things. Some of those prompts, the technicities of those prompts, how we speak about things, emphasizing certain words by saying them out louder, or gesticulating with the hands to add symbolic meaning to spoken language. Literally a computational equivalent to modulated speech, or Sprach melody. Of course, Benjamin Bratton and Blaise Garrett-Arcus noted in their essay Model is the Message that this leads to snake eating its own tail problems. They said, quote, nested within this is the Ouroboros language problem. What happens when language models are so pervasive that subsequent models are trained on language data that was largely produced by other models' previous outputs? Talk about biases. The snake eats its own tail and a self-collapsing feedback effect ensues. Well, the image of dream fusion I'm showing here is actually a very interesting feedback loop, which leads to refinement of the 3D output. So take a deep breath. I want to take a seemingly orthogonal step into geopolitics and cosmopolitics here. Asking again, for whom or what? Well, not who's talking to whom or what, but for whom or for what is this world? And I would say that what's at stake for us now is very similar to moments in European history which are not unique. I mean, I'm just looking at European history. We can choose many other places in the world. And this moment I'm remembering is a moment where Alexander Kojève wrote a recommendation to de Gaulle at the end of World War II. Now, the picture here is a picture of something from World War I, but let me talk about World War II for a second. Kojève basically suggested the French Empire was over. And the way forward, strategically, was to be found in France's potential to catalyze what Kojève called a Latin empire across all of South Europe and the Mediterranean and the Middle East. How's this related to psychopolitics, AI, humans in the loop, etc.? Well, Kojève's notion was that what would bind France and the Latin Empire together and create this new empire was a simultaneously linguistic, cultural, gestural, everyday life practice, and racial isomorphism across all those continents, even into North Africa. And this would make possible a coalition empire that would be built on a form of neuropolitics and identity. Very similar in a way to what Speer had attempted in 1933 at Nuremberg. So in a funny way, it's also not so different than the Middle European ambitions of the German Empire prior to World War I and up to the beginning of World War I. Germany was looking out to Baghdad in the early 1910s. And they actually built a railway from Baghdad all the way to Aleppo. It was finished, but when World War I broke out, that was the end of that project. So the question becomes, to what degree of neuropolitics is present or engaged in what we're doing when we collaborate with machine learning and AI? This concept of a structure of feeling, to use Raymond Williams, the great British socialist's term, a structure of feeling that will bring people to awareness, that will bring artificial intelligence to awareness, or, looking back to 1933, brought people to a fever dream where, to paraphrase Goebbels, they knew the words of the song in their dreams, without knowing how they knew it, and without even knowing that they knew it. So the psychopolitics we deal with today is precisely about how we see ourselves and constitute ourselves, how we label ourselves, and how AI then sees us. But instead of relying on low-resolution models and knowledge of neurocapture, today the sensors, the algos, the watchmen have a microsecond fine-tuned engagement with tens of millions of pulsing mind sense nets at once. So what will bring us to sapience, the ability to perceive self and think thought, as we contend with the imbricated systems of surveillance and control that we've built? And let's not forget energy. Go back to this interview with David Holtz again from a few months ago. David Holtz pointed out that in Midjourney, every image is taking peta operations, thousands of trillions of operations to make one image. Holtz said, quote, "It's probably the most expensive if you call Midjourney a service, like you call it a service or a product. Without a doubt, there has never been a service before where a regular person is using this much compute." And you have all made thousands of images using Midjourney. So think about the peta operations you've used, and me too. Okay, so let me try to segue into a wrap-up here. I want to go through the ultra-concert gesture, and then I'll tell you one more children's story to close. I'm interested in civilization, structure, collapse, new formalisms and ontologies. I'm interested in these concepts of gesture. We can go back to Leroy Gourhan in Gesture and Speech before I tell my final children's story. And we can talk about the neurophysiology of the gesture. Leroy Gourhan points out the operational synergy of tool, and Andrew, this will ring very deeply for you, I think. The synergy of tool and gesture presupposes the existence of a memory in which the behavior program is stored. With animals, this memory forms part of organic behavior as a whole, and it's instinctive. Now let's look at this beautiful little mouse. It's a fictional mouse that lives on a desert planet called Arrakis in the film Dune. This little mouse lives in a very harsh environment, so it has to conserve moisture. It only sweats through its ears, and it wipes its ears with its paws, and it drinks its own sweat. This is a kind of an instinctive gesture. Yes, it's a fictional mouse, but that's okay. It's the best part of that entire movie for me. Let's go back to Leroy Gourhan. The important point from Leroy Gourhan is the relation between cognitive development and the neurophysiologies of the human hand-eye-brain system. And we need to ask, how and where are those neurophysiologies being inflected and evolved in everything that we do today, technically? Leroy Gourhan says, well, the initial gesture is the manipulative action of the primate, and then we grab tools and we directly move things. And then we have indirect motility, where we have tools that are indirect. And then the hand intervenes to start a motor process. If you press a button and something works, like a mill or a water wheel or a car. And then finally, the hand is used to set off a program process, like what we're doing when we work with Midjourney and with Stable Diffusion. But this legacy of hand to eye to image to gesture goes back 35,000 years or more. 35,000 years is 1 terasecond, by the way. It goes back to the Chauvet Cave, which Werner Herzog talked about in his film Cave of Forgotten Dreams, a primordial site of early representation, notation, theater, and what Herzog calls proto-cinema. So the hand, mind, eye gesture is an ensemble. It's kind of prototype neurophysiological grouping, which we increasingly involve in the work that we're doing. And the larger question of how notation, labeling, and training that we're performing in the machine learning interactions and collaborations we do today, the question I have is, where will that plug into this neurophysiological system that's been operational on us for many tens of thousands of years? Who are we communicating with when we do this work, and to what purpose? So I titled this talk Distributed Cognition in Relationship to Cosmopolitical Projects and AI. And this phrase around distributed cognition and cosmopolitics has been stuck in my head for some years now. If we consider language and communications with non-human systems, AI, natural systems, the questions abound. What constitutes symbolic thinking, emergent language, or embedded quasi-pseudo-languages? And the question is whether any of these move from instinct to intellect. Does the mouse ever learn to think like we do? Should we want it to? Should we care? And where does intuition sit? And what might be a critical intuition that would be informed by experience? What's embodied computation in an open world? And what's the role of non-conscious or subconscious or semi-conscious cognition? Because I would argue that most of the AI systems we're working with right now are even less than subconscious. But they're all building to become something that is subconscious, then presumably sapient. One of the core problems in developing communication with extraterrestrial intelligences, which has been talked about by Oberhaus in his great book on extraterrestrial language, is the challenge of translation to a radically alien mind and cognitive system. So we can, of course, look at very good science fiction like the film Arrival, based on Ted Chiang's story, and ask again, who's communicating with whom and how? I could pull hundreds of pages out of Oberhaus's great book, but I'll just pull one page. The highlighted pink here underscores one really important concept. Oberhaus says, like Zipf's law, entropy is a universal feature of human languages. So quantifying the entropy of the communication system by analyzing the frequency of the units can help determine the complexity of the communication system and whether it even qualifies as linguistic. This is something that's very important for decryption and spycraft and all that sort of stuff, but it's also very interesting if you try to apply this rule set to how dolphins talk. To ask the question, as they did back in the 70s, the order of the dolphin, and all the people who are working on Mediseti, Carl Sagan, many other people, John Lilly, are dolphins really talking? Let's try to understand the zip factors and the entropy in what dolphins say to see if it actually is a language. There's a great backstory behind the development of the alien language in Arrival, which Stephen Wolfram and Stephen Wolfram's son were involved with. There's some really good thinking baked into that, but that's a story for another time. We might ask to link this example from science fiction back to prompt engineering when we make AI images. And the image you see on screen right now is a still from, again, Cave of Forgotten Dreams, where we have a human being playing an instrument that's very similar to primitive instruments that were played 35,000 years ago by early humans, or early modern humans. We may ask to link this to prompt engineering. What are the notation systems on top of physical systems, which blend human gesture and sense perception with a new class of ontologies of perception, which we're training today? This is what we're doing with our image generation and our spatial image generation as humans in the loop. And what new forms of politics are we crafting with our prompt engineering? How can this work be linked synesthetically to music, sound, movement, gesture across tens of millions of people? A little more than a year ago, I asked GPT-3, what would constitute a cosmopolitical gesture starting from Agamben's work on the gesture? And GPT-3 said back to me, the gesture is not over when the handshake is taking place, because one's hand can remain outstretched. This gesture, therefore, contains an element of potentiality for becoming actualized, and so does not yet have any final completion. So I'd like to conclude with another children's picture book story, illustrated with the help of AI. Thinking about civilization and structure, the body politic, human bodies inside architecture, as a system that stabilizes society, but it's fantasy structures that undergird human politics. What's the relation between the natural and the artificial? And what about the places where entropy, fire, decay, and wildlife overcome the stability of architecture? What is the heat death of architecture after fire and collapse, with the feral life returning to the ruins? Could this lead to a kind of deep structure, neoclassicism of form? What new formalisms and ontologies? What proliferations of synthetic life and mind are we building? If we meet the Buddha in the road, but she turns out to be the goddess Kali, what new formalisms might emerge? And if we are all dataless, designing the labyrinth, collaborating with AI, then who is Icarus in our world? And who is the Minotaur? Who is Orpheus in our world now? Who guards the gates of hell? What Cerberus do we as Orpheus have to face in a quest to find Eurydice? Who is Medusa? Perseus and Andromeda? And who is Daphne? Daphne, who transformed into a laurel tree. Our hands? No, Daphne's hands, as remade by humans and artificial intelligence. As Phocion said in Life of Forms of Art, Daphne's hands become leaves again. I seem to see primitive man inhaling the world through his hands, stretching his fingers into a web to catch the imponderable. My hands, said the centaur, have felt rocks, waters, plants without number, and the subtlest impressions of atmosphere. For I lift my hands on dark, still nights to detect the breezes, and so discover signs to make sure of my way. Let us recall the hands of Daphne, going beyond the human, as an act of self-preservation as she defends herself against Apollo and transforms, and the way the centaur can feel those unseen currents. Phocion again, quote, held against the wind, spread out and separated like a frond, they, her hands, urged her onto the fluids. They provided her with numerous and delicately sensitive surfaces for knowledge of atmosphere and of water. Her arms are becoming tree limbs. Already the extremities are leafy branches stirred by gentle breezes. To underscore the spatial architectural gesture as a metalinguistic notation and labeling system. The idea that the complex gesture as this metalinguistic and lossy codec may be both needed for us to go forward ethically and constitute the ground on which we do, and may indeed be at the core of teaching and learning a truly open-ended ontology, creating a true dialogue for us and with our AGI AI companions to come. Thanks, everybody.
Thank you, Ed. All right, so we'll begin our panel discussion. Not too far behind time, so not too bad. We have about 45 minutes, or even more. We have a big lunch break, so we can still talk for quite a while. So if I can invite Jenny and Andrew up, and then we're also being joined by Rasa Navasatite, who's a colleague and faculty here at University of Texas at Austin. And Ed, I'm going to try to do this where we can hear you, so give me a second and we'll try this. Ed, can you hear us? So we're in a surreal moment where your head is 10 times bigger than ours. Maybe that makes sense. All right. Yeah. Can everyone hear us? Is that okay? All right. Well, thank you. It was wonderful talks and obviously very different, all three of you. And I'll try to synthesize, we'll have a series of questions, but feel free to also ask your own questions for each other. But I'll try to synthesize a little bit, all three, into one topic, which is the idea of the generic and the specific. Ed mentioned it, talking about how we might no longer have generic names for things, like there might be a moment where everything's classified specifically. Mario Carpo, of course, in the second digital term, also talks about specific, how like Google, for example, no longer searches and classifies according to categories, but actually searches for the thing itself based on very precise information and data. So we don't need those kind of categorical differences when we're talking about computers. Jenny, you talked about AI as a potential bridge and almost a sixth sense, a way to start to communicate with something, so that almost a language or a sense between an installation and a people is a way to translate that information, actually help someone viewing the installation understand maybe the installation through the AI. So it actually might translate that experience a bit for that person, give them another way to read and register the work. And then ChatGPT, we talk, when we think about Midjourney or ChatGPT, it's not exactly data. I mean, it's data that we're dealing with, but it's not exactly truthful data in the sense that, one example that we've talked about online and between each other is, when you ask for a building, sometimes you get a watermark. And as far as Midjourney or these AI platforms understand watermarks is that they are part of buildings. They're not necessarily from the image. It's saying, when I see building, because I've tagged so many buildings, some of them have watermarks, and therefore that's a feature of the building. It's not actually something that's being produced from an image. It's being created as a feature. So my question, I suppose, is like, how do we think about our engagement with these tools when the engagement is not only with, like, these tools can call out very specific things, but they can also call out generic things. So I can ask for building, it gives me building. I can also ask it for very precise expertise. Like, it has very precise expertise on things that we might not know, like it can write a Python script, for example. How do we engage with these tools that are not necessarily truthful and accurate, but are giving us expertise that we're taking as accurate? And how do we engage with them in a way that still preserves that kind of generality to them, where we know we're actually communicating with all the samples it's used, all the people. Like its realism is based on all the people's input. It's not based on like the science necessarily or the facts. So how do we engage with that? How do we parse out truth from fiction when we're dealing with these tools or using these tools? Does that question make sense?
It's definitely something I'm struggling with. I'm teaching a class right now, just a short 5-week class for students at the University of Houston on AI. One of the big questions that came up is about this, of like what is truth. Just like immediately I was like, wow, when I'm teaching Grasshopper, it takes weeks and weeks for students to understand some really esoteric data structure or something like that. We're never really talking about big ideas, but within the first few hours of talking about AI, we jump to these large philosophical ideas. And I think one of the things I was mentioning to them in one of the first classes is that probably this year, like we'll collectively create more images than have ever existed in the body of everything we've ever done. It's just kind of crazy. There will be more synthetic, fake images than ever, like real photographs or real drawings or real paintings. So we're definitely in this age of kind of like the deep fake in a way, and I think obviously there's huge problems with that, but I think it also helps reinforce, like this is maybe a classic example, but that photography was thought of, like I said, at one point, and maybe in a lot of our ideas in mind still, is that it is true. But it's like, it's not, right? Like it's all, when you take a photo, you're taking a photo that is of one instant that you don't really know what came before or after, or you look at almost any photographer's work, even like Ansel Adams, if you look at the image of Yosemite or whatever it might be, is a fake image, right? Like you would dodge and burn like crazy to make it look aesthetically as good as possible. It's not reality. Reality and construct what the truth is. And I think these images, I don't know, I'm just going on now, but I think it's just, for me, like I said, it's like a reflection that it helps me realize more about the problems and the opportunities we have.
Well, maybe I can ask you about that. One thing that's so interesting is the disposability of images now. I mean, before, even back to like Piranesi in the prison series, the image transformed the discipline in many ways. Like we took these drawings and they really, they spread and they created a whole new culture, styles, transformed the discipline, transformed how we think about architecture. The Peak, Zaha Hadid, I mean, you can name any of these very specific images that really transformed architecture. Is that even possible? I mean, how do we value image now when we can produce 20,000 images that are all, one could argue, equally profound with equal implications on our field? How do we value those? What's the role of the critic in that? Like, how do we start to understand path forward through representation, or is that not the path forward anymore?
It'll be, I mean, all of us are constantly taking in millions of images. I don't know what our refresh rate is of our eyes in our brain, but essentially we are absorbing an infinite number of images. It's just crazy how much information we're drawing in, but we throw most of it away. That in our dreams we help form new memories and reinforce things that we saw throughout the day as meaningful and of value. And I think we constantly do that, like an image of the Peak or an image of whatever it might be. For some person it might be that it has no meaning. And for others it's like that helps form pathways in our brain that give it meaning. And I think, so yeah, with produce 30,000 some images in 6 months, and it's insane in a way. Like when I open up the archive button in Midjourney, you're just like, I don't even remember making that image. And I'm sure I looked at it for a split second and decided it wasn't worth it, or it was worth it, and I did a new variation on it. And I guess what I'm getting at is that they are cheap, although Ed would argue they're very expensive in another way, in energy. But I think it's the accumulation of them that help me form an certain memories and concepts around my desires. So, yeah, certain images that out of those 30,000 definitely stick with me, and other images from my peers. Here, all these images on the walls. I remember almost like the day when there was an image from Jose Sanchez that came up. Like, I remember just seeing that, being so impressed. So I'm not sure the cheapness of it matters that much, because I guess we already have that. We're absorbing so much, and it's up to our brains and dreams later on to help form what truly has value.
Maybe I'll jump in just to go back to your question around truth. With a related story, this is many years ago now, when I started working with now a longtime collaborator, the late Peter Lloyd Jones, just simply visualizing and simulating data emanating from his lab. And on the one hand, I was absolutely blown away by what they weren't doing in terms of modeling and looking at these data in different ways. And also blown away that there was an immediacy to my ability to participate. And part of that was technological, but a big part of it was just a way of thinking coming from a design perspective. But I was quite worried about a kind of similar question where I posed to Peter. I was like, well, how do we know if this is accurate or true? And he looked at me with, he was so confused. He said, well, I'm a cell and molecular biologist, and I don't even know what truth is, right, in terms of studying these systems. So it seems to me, to come back to your question, that truth, at least in my opinion, is present in what's absent. And I think that goes back to the biases inherent to the data that we all have spoken to. There's a kind of clarity, the obvious absence of data that underscores systemic entanglements of a lack of access and agency by peoples who are non-Western, are not white, are not male, etc. And also, I think there's truth to, Ed, you brought up energy, there's truth to the amount of energy that's being used to produce these images. And I think it'd be really interesting if there was an ability to see that in real time, right? To understand one's impact in that space. And maybe that's what you were trying to get at with your discussion around singularity in its relationship to truth.
You're good.
I think that's a really interesting question. Would we be able to track that in real time? It doesn't seem impossible. It seems maybe a bit difficult right now, but I remember in the register interview, Holmes was pointing out that they are using as much as they can pre-compute providers for Midjourney, and it would be nice to see transparency and accountability around that, so that all of those systems can be verified. I also think that the question of inclusion and the point that you just made about seeing the obvious absence of data is really, really interesting. If one was a tech optimist, one would say, well, but we're in the era of IPv6. Every person living on the face of the planet could have literally millions of IP addresses assigned to them, everywhere. And so if you wanted to catalog every tree in your town, you would still have millions of addresses left over. You could literally make it your project. You just put an IP address on every tree in your hometown, and they would all have a name, And so I think that the tech optimist would see that opportunity and say, okay, well, pretty soon we'll be able to track the energy. We'll be able to rectify the problem of absence of data. We'll have a non-Western data sets. The downside of that, and Jenny, you talked to this in your lecture. The downside of this is a lot of it will be surveillance. It will be acquired through surveillance and non-consenting surveillance. The class action lawsuit against the AI data sets right now is just the first step. There are going to be hundreds of them. And personally, I think that particular lawsuit is going to fail, and it doesn't seem well-founded or argued, but the principle upon which it's being argued is extremely well-founded, which is we are being harvested for the data that we have, or as artists or designers, we're being harvested for that which we've produced. And it's a very, I don't know, for me it seems like it's the core ethical problem that we face right now. How do we create radical inclusivity and also build a set of rules and laws around radical inclusivity which are both fair to everyone and also comprehensible to everyone? How do we hand off the concept of radical inclusivity and surveillance networks globally to a person who doesn't even know what a cell phone is? It's a very interesting problem. So I think that from a philosophical and an ontological perspective, IPv6 offers some really unusual opportunities to deal with this. It also, from a pragmatic perspective, offers some interesting opportunities, but it doesn't solve the huge design challenge of communicating to people, billions of people who don't have agency yet or access and who won't understand the nature of the problem. So it seems to me a huge challenge.
Picking up on that, something Jenny you said during your presentation about stability, open sourcing their model. Something I've been thinking out a lot about, because I've been going back and forth over the last 6 months between Midjourney and Stable Diffusion, and they kind of represent the two poles of Silicon Valley. So on one side you have proprietary big data, and on the other side you have the libertarian open source. And it's like, so like OpenAI, ChatGPT, DALL-E, Midjourney are kind of like the Silicon Valley closed proprietary system that harvests your data and then uses it to make the system more functional in some way, supposedly. On the other side, you have Stability saying, we're going to try to make these models as small as possible, run on really as minimal GPUs as possible, so you don't have to use the cloud. We're going to open source it all, give it away, so that anyone can build on the system. And both of them are really problematic in one way or another. You were mentioning like the issue of making something open source and letting anyone have at it when it's totally biased. On the other hand, should we trust Microsoft or Google or Midjourney, whoever eventually buys them, to hold all of our data and train the models on our data? So I'm kind of like starting at first I was like, oh, Midjourney is amazing, it's so great. It just produces beautiful images. Whereas Stable Diffusion wasn't always producing as beautiful images for me, and I wasn't really thinking about the political, economic, and cultural issues around the two different companies. But as I've gotten into it, I think I'm starting to come around as kind of anti-Midjourney in a way because of the closed source, because it's training the model like the images of the young white women who, I don't know if you've noticed, almost all of them have like little cuts and bruises as well. So there's that whole issue. And when I talk to Stability people they're like, we absolutely don't want your data. We are not harvesting it, we're not collecting it, we don't want any, as soon as it's computed on our servers, we delete it, we don't want any of that. And I thought that was really impressive in a way, because it's like, that's such an opportunity that all the other companies are kind of taking advantage of. But the other thing was about the aesthetics too, that it's impossible to not produce a beautiful image in Midjourney, because they're like setting the weights, the aesthetic weights, which is crazy that there are even aesthetic weights, which are biased in themselves, but that the weights are set so high that you can, according to traditional notions of beauty, you'll always produce something beautiful. Whereas with Stable Diffusion, the weights are kind of more average, and it's easy to make something ugly. And I was like, that's actually I want that freedom. I want to make something that doesn't adhere to traditional notions of beauty. So it's, Yeah, I'm definitely starting to like round the corner on like that the open, even though maybe it's irresponsible and could lead to disaster, that the open source model might be better overall because it gives more freedom to the individual.
But just to be clear, the Stable Diffusion, or the open source model, is still trained on data straight from the web. It's just not data that you've made within that platform.
Well, yeah, to be more clear though, all of them are trained on data from the web, and Stability is the only one being sued right now because they're the only one admitting it.
Yeah.
You know, that they're all using open source, like no one else has a 5 billion image pair, you know, there's that, right? So everyone's using it, but only one company's kind of admitting to it. So they have the target on their back.
I would like to ask as well some questions. First of all, very, very impressive talks. And I see a very different perspective into artificial intelligence and inspires us a lot. As we are here, architecture school, and we talk architecture after AI, I would like to ask you about each of your opinion and advices and thoughts through your experiences. First of all, very interesting relationship between human and artificial intelligence. I see in each of your work is very different. In Sabine, I see a huge and very nice relationship in the physical bodies of human and artificial intelligence through the installation work, which really nicely inspires how this interaction can happen and open up a new world to the science, to architecture, to physical space and physical entity as a human. I see a very huge inspiration in Adolf Keller's talk, which this phrase of access to the human intelligence through the AI. What does it mean? Like how we change our thinking in terms of rather than designing a building, like in a visual physical entity, we can access not only through our imagination, but through the history or maybe gathered research and wide knowledge. We can ask something we don't know and take this knowledge in consideration. That was very inspiring to me. And then I see Andrea talking about the freedom sketching and time issue. So within the students, we try to embed those tools. We see new perspectives are coming. What the artificial intelligence is opening up within the architecture. Maybe we are questioning more like a research perspectives in a quicker way. Maybe we can include within the spinning up assignments or strategies of design thinking where we would open up the worlds of creativity much more weight rather than, as you mentioned, by design making. We get a lot of criticism, like me sometimes, hearing the words that the geometry takes so much time, what is the meaning of it, and everybody gets tired of those processes, and the people need really high intention and patience. As well, throughout previous education, we have burned down difficult paths to achieve something, but today is not a question anymore. And so different ways it inspires. The artificial intelligence gives us a freedom of knowledge and even enjoying the process of creativity rather than having this very difficult path in achieving, time and consuming and so on. So I'd like to ask you each perspectives within this world. What are your thoughts? What you could share with us in the School of Architecture?
I can jump in. I think, for me, this new explosion also reminds me of previous times, not that long ago, when various technologies opened up new trajectories for wildly new approaches to creative design production. I'm thinking specifically the early 2000s to 2008 or so, when generative processes were possible in in architectural design. And some of the schools, SciArt, Columbia, and others that were starting to work with that, began to grapple with questions like emergence, complexity, etc. Just trying to make sense of what they were seeing on the computer screen. And part of that had to do with very specific platforms like Rhino offering the ability to tinker with Visual Basic Script, which there was no Grasshopper, there were no online tutorials. We were all teaching ourselves how to work with these tools. And questions of authorship started to surface. Are these scripts beginning to challenge the role of authorship and the designer that is developing these scripts? There was new possibilities for collaboration through coding, and it also started to bring colleagues together across disciplines. Here we were, architects engaging with these new processes, but borrowing terms from the sciences to try and make sense of what we were seeing. So I think we need to be, although I agree we're in this explosion that we haven't seen before, that we have experienced these moments in the not so recent past. And there are things I think that we can learn from that, both in terms of how we teach and how we learn in the studio, but also in terms of how we are sort of taking responsibility for these tools and the biases that can be inherent to them. So I think on the one hand, and just to go back to your comment, Andrew, I in no way am suggesting that there's one model that's better than another, but I think it's important that we maintain a critical standpoint, because if we look to other disciplines, industries, practices, experts in the misinformation space are completely grayed out, right? And I think we need to be mindful of the impacts we've done in a negative fashion with these tools. So I think it's exciting to see your sort of grappling and oscillation between the two, and I'm wondering how your students are equally reflecting upon that and the images that they're using.
Yeah, definitely. The first day, I was asking them what makes them feel most uncomfortable about using these tools, and the student mentioned, she's like, I'm an artist, that I sketch a lot, and I'm really intimidated by this idea that like something that might take me 5 hours to do, that I've always enjoyed in the past, now takes 5 seconds to do. And she's like, does that devalue my own work? And it was really interesting to just hear her say that, and to like think through like what are the repercussions of. And I think that's what mostly what the lawsuit is about, of artists feeling that their work is being stolen and people can emulate their work. I think it's going to be hugely challenging. I definitely feel for, especially one of the I forget what it's called, but one of the people who that lawsuit is about is an artist whose work was, she's a cartoonist, and originally her work was kind of co-opted by like right-wing crazy people, like taking her artwork and turning it into memes to like say things that she didn't really say and things like that. And now she's like, now I feel like I'm victimized again by the whole AI industry. Now anyone can create, work that looks like mine. So yeah, I think it's hugely challenging.
But it also touches upon new forms of value around data. A big part of why her work is being co-opted is because there's so much of it on the internet, right? And so you mentioned in your talk that you strategically avoid certain prompts that would include those data. And so that criticality, I think, can become part of one's design process strategically in the crafting of the data, what is included and what is not included.
Yeah, it's interesting. You mentioned
What Ed had mentioned at the very end there, the 250,000 prompt data set that was made available, I used that software and that database to see who was being prompted within architecture. And I entered in all 50, or not 50, I can't remember how many Pritzker Prize winners there are at this point, but however many there are, I put all their names in and looped through, and like how many times, this is from June to July 2022, so it was very, very early on in the beta of Midjourney. Not a lot of architects using it, but it was like, out of those 250,000 prompts, like 800 had Tidal Ondo, maybe 500 had Zaha Hadid, and then like Gary had, I don't know, like 10 or something like that, and then everyone else was at 0. So it's, yeah, I mean, I think it's getting better at certain people, representing or re-representing a certain architect's work very, very quickly. If that was only 1 month before really any architects were using, or very few architects were using the platform, when all that data gets fed back in, I think it's a huge problem. That there are certain figures that I think have influenced all of us in our careers and our work that are completely kind of unknown to the model, and then others who are very popular, but like maybe not as influential overall to the discipline, are like overrepresented.
It's interesting, you mentioned like earlier the photograph, and Walter Benjamin would say that when you take a photograph in the age of mechanical reproduction, that you lose the aura of the thing or the origin of the thing because you detach it from its context. It's a reproduction elsewhere, and it needs the context in order for it to be that work of art. So, with artists, I think that argument can be made that as soon as it's detached from its thinking and its meaning, that maybe it loses that originality. I want to ask you about sketching, because you and I both used the term sketching before, and I think it's an accurate description of how we're maybe embedding this within our design process. But if we project forward, which we should be prepared for, it won't be as, first it won't be image-based for too much longer. I mean, I think 3D models are on the horizon. The accuracy of those 3D models are probably not too far off, and before long, people will very quickly and easily be able to produce architecture, real buildings, plan sections, things that can be tested through generative other models. Once we get to that point, how do we start thinking about our expertise or role within that realm where we're no longer the translators of this two-dimensional information into something 3D?
I mean, first of all, I think, 3D is definitely coming if it's not already here. But I'd say, I'm not that interested in it. Maybe it'll get a lot better, but I have a feeling early on it's going to be a lot of really bad topology, no real intelligence, let's say, in that level. That it's going to take a long time to get it to the point of Grasshopper or Revit or anything like that, where you have fine control over dimension and modularity, things like that are essential in the construction of architecture. I think it's easier to lie in an image, let's say, right? Once it's in 3D, it's going to be so real that we're going to see a lot of the major problems of how the models are constructed, the 3D models are constructed, and how poorly they're constructed. And I think we should take advantage of this. Hopefully the main point of my talk, take advantage of the fact that we can have this ambiguity and incoherence within the image, and that's like a positive, I think, for us as designers, because so much of our technology has focused on gaining greater control of every little bit of geometry in incredibly complex ways. I think it's good to step back and not have a tool that we're not worried about all of that. Not worried about the generative logic of how every part is nested into another part and so forth. But instead something that is quick and helps us explore more. So for the moment at least, I'm going to resist the urge to 3D, and maybe at some point, who knows, maybe it's a year from now, maybe it's 10 years, 15 years from this, that it will get to the point of fully being able to produce a piece of architecture that has been rationalized. But I think it's going to take a long time to get there.
I'm curious, Corey, when you say it will be possible to produce architecture, what do you, I mean, because the conversation right now is largely upon image making, aesthetics, creativity within, wildly amazing, sublime ornament and structure. There's a long history of that in architecture, and I'm just like, what do you mean?
Maybe I should say buildings, because 70% of buildings are not designed by architects. They're made by developers, contractors, based on pretty rudimentary bad plans. I don't think that's so far off. The ability to take the data sets that we have already of all the housing that could be, you look at a project in Dallas versus Oklahoma, wherever, and then the same project. So you have all of that data, just like Andrew mentioned, which once you accumulate a majority of a certain kind of data, the model's going to produce that kind of output. And so that's what maybe is coming our way, where we produce buildings and not really architecture. But there's going to be, that's a desire people will have, not architects, but people who want money through making buildings, to use these kind of models to produce plans, sections from these data sets.
Yeah,
How do we intervene within that?
I agree, but I also think there's an opportunity, and there is already, I think, a number of examples of work that is working with alternative data sets to explore, for example, indoor air quality, thermal comfort, the spread of infectious diseases, and the analysis of architecture, urban street systems, and transportation systems through the use of machine learning and AI to bring clarity to otherwise intangible aspects of data structures that we can then leverage as architects, in amazing, amazing ways. And so I think there are some limitations to the platforms that we're working with now, and I think they're geniuses as sketch tools. They open up new avenues for creativity and form making. But I'm excited to see in the not so distant future how we as architects begin to craft particular data sets towards architectural intention and application that allow us to work with energy systems, dynamic data sets that otherwise previously we could not possibly work with at all, and bring a design process to that, right? These dynamic conditions that we can't even see into an architectural context, and that was the data and the initial conversation from the real import of the project, and that was largely also based on Doug's expertise in developing AI platforms to detect subtle changes in our environment that influence us, that otherwise we wouldn't be able to even understand. And I formal-based production, but with much more strategic uses of the tools.
Yeah. I think what's so interesting about your work is the transdisciplinarity of it, and I think ChatGPT only makes that more expansive. Or any of these tools, like when I work on a research paper now, I found it remarkable how I can ask for references and citations. I can give a topic, not have it write the paper, but just say, what references should I look at? Where, if I go to a library, which book should I pick up? And it's remarkable at connecting dots between different references. And I can see the same thing happen in a transdisciplinary realm where you present the project and say, what other disciplines am I missing here? Like, what other avenues should we be connecting to? And yeah, I think that's totally amazing potential where it starts to become a collaborator, your own kind of discipline, but also one that's connecting other people that might not even be part of that smaller umbrella.
To rephrase your question though before about that, in a way it was like, what do architects do when AI might be doing everything that we currently think of, right? And I think the introduction of photography obviously didn't kill painting. It just changed what painters were interested in and what they could do. And I think it'll have a similar effect as these different AI tools. It might just be, it might be sketching, it might be rendering, it might be 3D modeling, whatever it might be. that clients will have access to these tools. So they'll beg the question, why am I going to pay someone else to do this? And we'll have to figure out how to add value to that. That we'll still have our expertise and our ability to make choices, I think, is I've talked about this somewhere else, but I think regardless of the content of any of the images that I've made, I think it's changed the way that I think. You know, anyone looking at 30,000 images and making a choice about it develops a certain sensibility about that, right? You know, about whatever topic is. And I think so. It's like, as much as my data is training an AI or whatever, I think it's also just the process of selecting and all that is making me a better designer. At least I hope it is. And I think because it kind of mirrors the architectural education, right? Like we do a bunch of sketch models, a bunch of sketches, figure out which one is the best, and we build on from there. And then we make a bunch more, and we choose the best one. And it helps over time, over 5 years, over a lifetime, we develop an intuition about which selections make the most sense for the current criteria. And I think the average client won't have that kind of archive of memories and intuition to help them. So they may be able to, like, I can take a photo, right? But I can't take a photo as good as a photographer. And I think it'll be the same problem in a way, that there will still be a need for expertise, and it just might be that.
Go back.
Just
And I've been here the whole time. I just think that the audio was glitching because of the video stream. But if I can appear like the wizard, there's a couple of interesting, crucial questions. One is how we define design as we can evaluate ourselves as good designers. And I suppose I would take a little bit more of a non-anthropocentric position on this and say that as designers, we're always channeling whatever history we can gather through the work that we've done and through the study that we've done, the discipline that we have. And we're making our best attempt at synthesizing and critically choosing what prior forms from history we've been exposed to and we've lived with and we've studied, and driving them into stress will presumably have as good or better experience. But I also feel that this is a very scattershot process. None of us is a mentor. I've only met a few people in my life who have, you're totally cool. I remember you to Saffron. Some of you may know you, is one of those people who seems to be just capable of remembering almost everything and synthesizing it with a kind of biting wit at almost any moment. But I very rarely have met anyone who can reach out to the library of books. I have hundreds of architecture books behind me, behind this AI image, and grasp all the ideas and synthesize them quickly. And this is what we try to do. This is why we spend so much time doing what we do. But rarely do I ever feel like I've successfully achieved it. And hence I have a huge library, which I refer to all the time. And the process that we have just gone through in the past year and a half has exposed us to that limitation of human memory and mnemonics. But it's embedded us in a system where we have at least a fleeting glimpse of a grasp of a system that, although not nearly as intelligent as we are, has much more rapid access to the entire data set. And so the question of what it would mean if we collaborate with an AI system that knows a lot more about human well-being than you or I do, it seems to me is one of these really profound potential sea changes in the work that Jenny is doing. The only Achilles heel there, though, is did we make the right choices about what well-being is? I think about the Cybersyn project, I think about Chile and the failure of that project. Of course, perhaps it failed because we didn't have enough computation and enough planetary networks at that point. Perhaps it failed because the Allende was overthrown. Perhaps it failed because second-order cybernetics just wasn't ready yet. But I think about projects like that aimed to have a real-time metric of population satisfaction and happiness, and to create a governance system and an industry system that would respond in real time to sentiment. And it feels like we're getting very, very close to that, but the model of what well-being is what's at stake. And I guarantee you that most people's model of well-being, mental health, well-being, physical health, well-being, spiritual health and well-being, is going to be different than yours and mine. Yours is different than mine, and mine is different than yours. And so achieving some kind of workable average, which has been what government has tried to do for thousands of years, a workable average which maybe is more forward-thinking. This is why I mentioned Raymond Williams, the socialist, because his idea of structure of feeling, it's something that happens when hundreds of thousands of people live together for decades, and they all work in coal mines, for example, and they all listen to the same music in pubs at the end of the day, and they all drink similar beers, and they all wear the same kind of jeans or clothing, and that's a structure of feeling. And it's an economic and a political agency structure of feeling too, because they all have been repressed by labor practices and laws, failures of government, classisms and racisms, and that creates a structure of feeling as well. But it's intuitive, right? None of those people, none of us, are fully aware of the platforms that we comprise and that build us and give us or take away our agency. And it seems to me that one of the huge sea changes right now, and Jenny, from your talk and the work that you've done, your work that I know, it seems like you're trying to take this on in a number of different ways. It seems like the sea change we're going through right now is we have greater access to the technicities of those platforms, but the Achilles heel is we don't. But we don't have consensus, and build that consensus. This is, I missed a couple of comments after one of the panelists' questions, who was talking about architecture school, our relationship between human and AI. So I missed some responses, and I run the risk of duplicating something that's been said. But it seems to me that this is one place where architecture has always worked. Because architecture could claim sometimes to be able to respond to a consensus problem of social design and social engineering, but it also could be said to outlast those questions. I guess I'm a child of Chile in some ways. I'm interested in cross and trans and against the grain programming because the function of the building can shift, but the building can remain there as a kind of a stubborn insistence on its presence, even when the church becomes a nightclub, right? The church works just fine, psychologically, as a nightclub, as much as it does as a cathedral or a mosque. And so, in that sense, it might be both the strength and weakness of architecture, that if we're interested in building something permanent or semi-permanent, it can stubbornly resist the changes, and the amphitheater can still be a place where different forms of theater take place, even if it's occupied by a fascist regime. It still is a place that holds up against those changes, those kind of fleeting changes of social body, of political body, of cultural body. And so I think for us as architects, it really ends up becoming, initially, before the architecture after AI discussion, it becomes a question of the degree to which we want to put architecture into the world as a tool that resists those kinds of fleeting changes or stimulates an awareness. There was a conversation between Wigley and Eisen years ago in their ongoing series of conversations where it seemed like really what Peter was arguing for was architecture and monuments' ability to leave a message for future generations. They wouldn't be able to decode, but at least they would know that someone had tried to leave a message. Whereas Mark's position, it's seen in this conversation, was that architecture's role was to stimulate the population's ability to be aware that they were present in the moment, but not so much that they should remember historical awareness. That architecture would create this profound awareness and event of the punctum of history. And those are two very different opinions, obviously, about what architecture's role could be or the role of the city. Let's say that we take that argument between Mark and Peter, and we transpose it into the conversation we're having today, and ask the question, okay, so what does it mean when those structures of feeling are accelerated and the technical platforms are deployed in a way that's profoundly different than was ever possible in history? I don't have an answer to that question. I mean, this is what I've been trying to work through for the past 6 months or a year. But it seems to me that that's kind of part of what we're talking about. And of course, the end user and the end population and the structure of feeling of all end users is profoundly different. And so perhaps architecture can't answer any longer. But it was more than a century ago that Victor Hugo argued that the book killed architecture, and that Foucault argued a bit after that engineering killed architecture. So it seems like this conversation's been rehearsed a number of times in the past.
Thanks.
All right, so I think we have a few more minutes. We've gone a little over, but we have a little bit of time. So I think we'll open it up to the floor here. It looks like Cisco has a question.
Yeah, this has been a fascinating set of presentations and conversation. It's hard to, I'm curious in terms of that last comment, to what degree the human well-being is automatic in this evolution, because it doesn't seem automatic at all. And I don't know if there's conversations within the discipline about how to preserve that as a value, if that's something that happens. That's not my question, but it was just prompted by this last comment. My question really was about, there's been a lot of talk about the productive capacity of what do we call it, disembodied cognition or disembodied computation. And certainly, the idea that as of the standard of 2 years ago, we can now produce in a couple of months the same number of images that we would produce in a career. I mean, it's hard to imagine that doesn't devalue the image in some way, just kind of by supply and demand. My question is about not so much on the productive side, but the consumptive side. It's been touched on a little bit. Surely this technology is using a lot of energy, right? Consuming a lot of energy. But it seems like it also has the potential to be actually not the user or the end user that's been talked about, to be that end user or end user, right? The idea of the snake eating the tail, and that these images are so profuse that they're impossible for humans to absorb, makes you wonder whether the technology is actually the place where the consumption of these images will primarily happen. It's not lost on me that of all the autonomous car companies you see driving around Austin, that there's someone in that car and it's probably taking 1,000 images a second, and no one ever sees those images. They're all feeding back into the database being built by the mapping, whatever that these companies use. And so I wonder, I think that I guess my question is, to what degree do you all think about consumption as non-anthropomorphic or non-anthropomorphic, centered on human consumption? And will that play a larger role? I'm just curious if these conversations happen in these dialogues.
In my own consumption of them, like I said before, they're almost like flickers of light on the screen. I barely consume them, and I've referred to them as sketches because often, I still have a sketchbook. I don't use it as much now. I just have a big piece of paper underneath my keyboard, and as I'm working, I'm usually like writing things down, sketching things, and inevitably that piece of paper gets coffee stains on, and I recycle it. But like the sketch, what I'm trying to say is that the sketch doesn't have that much value in and of itself, or the image of the AI image doesn't have that much value in itself. It's more part of the iteration and the process. And I think one of the things that I most like about going back and when I'm not generating, but I'm consuming the images, let's say, when I go back into the archive of my work, and it's like, I see how my mind went from like one idea to another idea to something else, to then get totally bored and try something else completely, or go back in time and restart a prompt that I had previously. So I think it's on one hand, it's incredibly cheap and you consume so many of them that they almost have no meaning. On the other hand, the fact that it's all archived and there's a genealogy of the generation that can then be kind of restarted at any point, I think has great value.
You know, one thing I'd add, so I don't want to jump in here, but I'll just say a quick thing, which is that one, I'd say, defense of Midjourney is that it stayed on Discord. And so part of the consumption and production of images is part of that community where you can see what other people are doing. I mean, when we first started doing this in the summer, you could see what Andrew was posting, what I was posting. And so we were all building a common, I think, language of working with this thing. Like we never would have, if it were on our own, we wouldn't say Octane render. It's just, you know, everyone knew that's what you did to produce a certain thing. And so, I mean, there was some really interesting like consumption that was happening and simultaneous learning and collaboration that was happening even with people you didn't know. And so that was an interesting moment within it that maybe gets lost as it starts to become a software, where it starts to move away from a platform or a service into something that's isolated from others and you're working more as an individual.
I also know that we've experienced that before with different technologies, and you know, I mentioned this previously. But it was so exciting in the early 2000s when we were working collectively, engaging in international dialogue through various organizations, and this Smart Geometry group was it like a think tank for experimentation, passing USBs around and giving all of our computers viruses. And then I think there was something lost when it started to become more packageable and there was more ubiquity to the tools. And now there's just too much, right? In many ways, just really tune out quite a bit of it to be productive. So I'm fascinated, and maybe this touches upon your really excellent question about those kind of loops that happen in these technological leaps that inspire collaboration and collective consumption and sharing, you know, to push it forward.
I mean, I love, like, Ed, you showed pictures of, like, Andrew's Instagram or Matthias's comments. I guess that's now the place that we communicate and share with each other. But it's really interesting, because, like, when computers came around in 2000, Greg Lynn was the one probing the tools. You know, what is a curve? What's a spline curve? How does it relate to architectural theory? How do we use that as a way forward, as a discipline? And now maybe it's this kind of probing you're doing, Andrew, where you're looking, you're testing the tool, you're finding, like an experimenter would. You make a hypothesis, and then you research it, and then you come up with a conclusion. And I think it's an interesting way to then share that through media and expose what it is, but also share that knowledge. So continue to do that, please. Any last questions? Okay, one more.
I have a question. Coming from practice, thinking about applicability, I haven't looked into this myself, but the text-to-image engines and their end-user license agreements, so they speak to copyright through the images that they're gathering, are probably part of the class action lawsuit. Makes me think too about map makers and their tactics of adding fake streets and parks to sort of understand that their image or their content is being reused. So from a practice standpoint, that might want to try and practically apply this now. Are you aware of any, or what is the end user license agreement related to that, if there is one?
So Midjourney, or you maybe remember this better than I, sometime in early June, they changed the end user license. Previously, they owned everything, and you just made it. And they changed it in June, I think, mid-June, that you own the work, but they have a unlimited, infinite license to all of your data. So, you know, yeah, because it's just like Facebook or Instagram. They want to be able to use that data I mean, in the case of Instagram, it's to advertise to you. In this case, it's to make them all better.
Some questions maybe.
theorist in a room with people who work with technology is daunting, to say the least. But it seems to me that what we've been what's being talked about as a kind of, inherent bias or the tropes of, say, normativity that we can identify in any of these produced images, is a result of a kind of archive that the machine learns. Is that correct? Is that a correct analogy? And that then if with every subsequent set of images, the question I have is, does that archive then grow? In a sense, this is the opposite of the Foucault problem of the archive, because the Foucauldian problem of the archive had to do with the selectivity and the curation of that knowledge set within it. But it seems to me that what we have in front of us is more Borgian, if you will, that it's a sense of a kind of really radical, even kind of post the open work and into something that we might even call the open archive, that is maybe, and this is my question, is it then incumbent on us to then produce as many images as we can, whether we see them or not, so that difference actually becomes imbricated into the archive rather than normalization? I mean, in other words, not producing wideness, but really producing difference, qua difference.
So it's a great question. There's a few different answers to it. I can see Kyle wanting to jump in. But so there's the initial training data, which you can kind of think of it as everything that's on the internet, kind of. So even there, it's like problematic, because anything that's on the open net, you could say is fair game. At least that's what they're scraping. But then there are like closed nets that a lot of data exists, and a lot of valuable data, you could say, exists. And I think there's a reason why, like the YM5E data set has 2.8 billion images that are English and not Chinese, right? That it's just not able to scrape the Chinese internet in maybe the same way that it's able to scrape the more open internet. So there's that issue, that it's like it's just scraping everything. The second part of it is that the model, the way the model is trained, it looks at all these images, it then destroys the image successively into noise, and it doesn't remember really anything about the image. It just remembers the relationships between certain, like, and Kyle, feel free to jump in if you want, the way to destroy something, and it remembers how to undestroy something. But if you give it a new set of noise, it will then try, almost like looking in the clouds and saying, like, oh, I see a picture of a dog or whatever, or a tree, that it will try to, even though each cloud might be different, that your brain has been trained to look at the world and try to make sense of it.
Does it sort a la the arboreal kind of metaphor, or does can it go rhizomatically across these image sets?
The tags are generic.
It's not drawing from a database.
Yeah.
Right. So I think that's maybe an important thing to know. So there's 4 billion images in the data set, 5 billion in which it was trained. It can generate far more images than that. If it produced 1 image a second, it would not produce the same image past the depth of the universe. I mean, like, it is functionally infinite.
But would the images that it produces become equivalent to the images it originally learned from?
Equivalent to who?
To the others. So like, in other words, does it turn images into any kind of hierarchical decision?
There's an ontology in place. It does think of things in an organized way. And that's what they call latent space.
Can we untrain that?
If we make more images in a particular category, will it learn those images and start referencing those more than the other ones that we already have?
In a sense, but I'm also asking, is there a way to de-essentialize it?
Yeah, I mean, part of it is tagging as well. I mean, that's the language it does understand. Like, it understands what doors are, like really generic tagging. It could be that another language is invented by a group of people that tags things differently and then maybe call upon those tags to produce a more specific result that might be defined by more specific parameters,
Well, isn't
rather
that-
than the generic,
Right.
biased ones we have.
But then wouldn't that then be the goal for architecture? I mean, to me, I think the problem of architecture that we inherit from classicism and modernism is the sense that it either had to be essentialized or universalized. And and that kind of ultimate goal of the normativity of architecture is what we're all, hopefully really deeply engaged in that battle, because that's exactly like, engaging the normativity of whiteness, that it's, that this is not the way we go forward with this field that we have.
I think the biggest problem that I've been dealing with, and I mentioned it previously, is the aesthetic weighting. So there are these 5 billion images. Another script was written that cycled through all of those images and then gave them a score from 0 to 10 on how beautiful they are. Now, who made that model? Right? So then you have to go back, and it ends up that it's probably some poor grad students being paid minimum wage, just is this image good? Is this image not? And essentially, and kind of oddly, there's no images, or very, very few. I think it's 0.000%. It doesn't even list some beyond that. There are no images that are between 0 and 1. So that we get to find the ugliest image in the world. And there are only a few thousand images between 9 and 10 on this weird, artificial judging of images. But the thing with especially Midjourney is that they're essentially putting their foot on or their hand on the scale and saying, we're only going to allow you to produce images. No matter what prompt you put in, it could be garbage. And you're always going to get an image that a lot of the biases come in, because it's well, who thought that original image was beautiful? What were they trained on? What art class did they take? Or, so there are a lot of normative standards of beauty built into the model because of that.
But this, what Midjourney actually does, it's owned by David Holtz, an entrepreneur, the CEO, and he makes every week he makes a lecture or a hour, you can listen in, and asking questions, and he very clearly says that he has this project. This is what you're talking about. He actually assumes a project that he wants to make the world a better place by, in a way, lifting up aesthetic quality of art. And he makes very clear, he says he excludes certain kind of tag words. He makes that decision. So we have, in a way, already architecturally, someone is a subjective project.
I mean, he said that he's I want to make it almost impossible to, we have a certain aesthetic at Midjourney, and I want to make it almost impossible for you to make something that looks like a photograph. I want it to be painterly and artistic, and that's his goal as the CEO of the company. And it's incredibly successful. These are really amazing, beautiful images. But I also kind of resist that too. I don't really like that power is in one person's hands, and that what he's judging, and he's using a tool that was trained on maybe a few thousand people's ideas about beauty.
And one proposal that's very much in the air is that we could each have our own personal Midjourney, right? That we get to set the aesthetic guidelines for as individuals and push in different directions, right? I'm not sure how feasible this is in the future or how desirable this would be, but this is a claim that is in the air.
This is stable diffusion stack.
Stable often makes that claim in response to concerns about bias or cultural difference. There'll be an Indian stable diffusion, and there's already a Japanese one, and these could apply to cultures, but subcultures.
All right, I really hate to do this because it's an amazing conversation. It's always panel discussions always do this. Right at the end is when it really gets hot. But we do have another session, so we can keep it going and stay as long as we want, I guess. But we have lunch now, so an hour break, and we'll be back at 2 o'clock.
continue? Okay. Welcome back. Welcome to the second part of the symposium. So welcome to the second panel today. We have three speakers, Kyle Steinfeld, Martha Nowak, and Sophia Kasper, who will join us later via Zoom. So, of course, we not only, or we already liked the discussion during the break, that this house symposium is not only about image generating, but generally like AI. And I thought to be more neutral, to compact more or compress more the CVs, or to introduce the speakers more with each 100 words. I asked just simply ChatGPT to do that. And so sorry if
we'll see.
It's full of lies. Yeah. Okay. Please welcome Kyle Steinfeld. Kyle Steinfeld is an architect and software developer based in Oakland. Through his work, he aims to explore the potential of computational design and blur the lines between rationality and whimsy. His interdisciplinary work has been exhibited at Neuro IPS and published in Towards Data Science. He has also published several works in design and computation, including Geometric Computation Foundations for Design. Steinfeld's research examines the relationship between creative design and computational methods, and he has received various research grants and fellowships, including the IDEA Fellowship at Autodesk and the Hammond Fellowship. Please welcome Kyle Steinfeld. Surprisingly pretty accurate. Everyone can hear me okay? Awesome. Thanks, Daniel. And of course, thanks to everyone here who's awesome for having me, Corey and Clay, everyone who's involved in making this event take place. We've been asked to talk about where things are going, I think. What it might mean for architecture to be, quote, after AI. And I take this as a call to look forward to a time in which the technologies and the tools and the processes that kind of are captured under this relatively large umbrella that we say that we use in AI, to a time when those have become ubiquitous. Of course, it's awfully hard to predict the future, especially when it comes to fast-changing subjects like this. And like many sort of amateur historians, I think the best guide to the future might be our past. So as such, I'm not going to spend the bulk of my time today speculating on the future of ML in design, but rather talking about what has brought us to this moment, because I think it can help us illuminate it. So a part of this will be to address the specific technologies that have brought us together today, I think, as a kind of immediate catalyst. So I'm speaking, of course, of Stable Diffusion, Midjourney, DALL-E, other text-to-image generation tools that suddenly and very visibly made their way into the public consciousness in the summer of 2022 and that cover the walls, or the results of which cover the walls around us. I'm going to spend a bulk of my time today talking about the kind of social and technical context that led to this. Just a quick show of hands. Who was at Acadia in Philadelphia a few months back? Right, you might want to get a coffee during this break. It's very simple. But there's more, I promise. If I could ask you, so that's part 3. Part 2, if I could ask you to indulge me in not one, but 2 threads in the history of technology. And actually, I'd like to begin by talking about why this moment in time might hold particular importance to the role that computers play broadly in shaping design culture and in practice. That is, to talk about the rise, what the rise of ML tools might mean to the instruments of architecture, how architecture proceeds. In other words, what does this mean to CAD, to use a very sort of pedestrian term? Can it make CAD more human? Before I get there, I'd just like to start by offering some context of where I'm coming from personally. That is, some kind of like brief notes on my position on design technology, sort of writ large, like how I see things and where I'm coming from. And then I'll wrap up with a very, very brief reflection and some questions for the larger panel, which will take place in like an hour. So try to keep that in mind, I suppose. So I think it's always good to start with this kind of thing with a kind of statement of values. I talk about like what drives me and how I position myself. I'm also going, as I talk about that, I'll show some of my creative work, which I'm not going to really address directly. So in broad terms, I'm interested in humanistic applications of technology, specifically, of course, in the context of computational architectural design. Generally speaking, I'm an advocate for augmentation, human augmentation, not automation. I see the systems that we currently call AI as sort of cultural technologies, much like writing or print or libraries or internet search engines or even language itself. These are fundamentally techniques for transferring knowledge among groups of people. I took note in the morning when Ed Keller evoked the image of a person surrounded by books as being sort of limited by not having memorized and synthesized all the facts in that library. And he described AI as a kind of partner that has done that, right, or could do that. It kind of extends beyond the capabilities of a person. I don't see it that way. To me, AI is less like a different kind of person in that room and more like the library itself. It's a technology that's an extension of the intelligence of a person, and it fits into a long line of technologies that are an extension of human intelligence. So the idea that AI boils down to connecting people to the knowledge of other people is not to discount anything whatsoever. That's very important technologies in the world to do exactly that, right? In fact, I find it really interesting because I see creativity as a network phenomenon. I understand design tools in that process to be kind of cognitive instruments. We could say intellectual prosthetics, right? It's something that extends us and helps us move beyond the kind of knowledge, skills, and abilities that we have, that we don't hold, that we might not have access to otherwise. So I don't know how, for example, to calculate a perspectival projection using Euler angles and et cetera of a 3D model, but I've got 600 years of graphic projection at my fingertips in my CAD model at all times, right? Brunelleschi is in my laptop, and I see AI as sort of being very similar. And so finally, sometimes comes up, so I just want to stick some ground here. I'm skeptical of certain aspects of the whole kind of post-human thing. I see autonomous sort of quote-unquote machine intelligence or general artificial intelligence as to be like a total red herring in this conversation. It's a kind of a different thing. We're calling it AI, but it's really, really generative statistics. It's linear algebra that we're talking about here. General AI, it does not exist yet. It won't anytime soon. And I think it's a distraction from the real social impacts that this technology holds. So this is fine. So while I work in design and technology, my interest in ML as an instrument in design, it stems from a kind of basic disillusionment with the existing state of computer-supported design, broadly speaking. I'll touch on this more in a bit when I talk about what AI or ML can mean for CAD. But just in terms of background, when I first started working and writing about the potential of machine learning in architecture, this was 6 or 7 years ago, in like 2016, 2017, the landscape was quite different then than it is now. When I first started working with these systems, there were none of the videos are working. There were none of the kind of foundational models, the quote-unquote foundational models that power the tools and the apps that we have today. It was very difficult to engage with this stuff. Training and running the models that produce the synthetic images that I'm showing behind me, these required purchasing a standalone Linux machine, learning how to operate Linux, spending $3,000 on a GPU that could run these things, 3 days of setup time, understanding libraries like CUDA and TensorFlow and NumPy, things that I had no idea about. Weeks of training before the first image was even produced. It was a tough time. There you go. And this is more recent work. It was tough in that moment, and it kind of gradually got much easier. In fact, the most kind of pronounced change that I've experienced as a kind of creative ML practitioner across the past 7 years had nothing to do with the rise of Midjourney or Stable or anything like that, but rather related to kind of how the infrastructures of machine learning have made things much easier and much more accessible, and now neural networks are kind of quite easy to access. And this has been kind of my view of things. This moment's an exciting moment for me personally, because I can see the creative ML, after years of working in this area, is moving quickly from the domain of relatively obscure systems that are only accessible to a small, dedicated handful of experimentalists, as I've been in the past, and into a much more accessible domain that more closely resembles something like commercial software and easily accessible services. So this is an important time, I think, to think about what aspects of the experimental phase we hope to carry forward, what's worth preserving, and what opportunities and sort of risks await us in this new era. So, speaking of opportunities, one thing I'd like to do today is think through the potential impact of ML tools in design, and think through that in the terms of the role that computers play in shaping design culture and practice as they stand now, and how the future might be different. So this means talking about CAD. So I'll ask for your indulgence, fair warning. You're about to see a really super cool 60-year-old CAD history.
I'm John Pitt, MIT science reporter.
Is it audible?
We're at MIT's Lincoln Laboratory in Lexington, Massachusetts, a major research organization which has played an important role in developing the nation's defense systems since World War II. And although Lincoln Laboratory is perhaps best known for its work in radar and advanced warning systems, it has also seen the beginning of the computer era and has made many important contributions to it. To learn about some of its recent work in improving the relationship between man and his important machine, we talked with Professor Stephen Coons, Associate Professor of Mechanical Engineering at MIT and co-director of the Computer-Aided Design Project.
John, we're going to show you a man actually talking to a computer in a way far different than it's ever been possible to do before.
Surely not with his voice.
No, he's going to be talking graphically. He's going to be drawing, and the computer is going to understand his drawings. And the man will be using a language, a graphical language that we call Sketchpad, that started with Ivan Sutherland some years ago when he was busy working on his doctoral degree. And you will see a designer, effectively, solving a problem step by step. And he will not at the outset know precisely what his problem is, nor will he know exactly how to solve it. But little by little, he will begin to investigate ideas, and the computer and he will be in cooperation, in the close cooperation in this work.
So what did we just see here? This is 1963. We're looking at Stephen Coons. Stephen Coons is the creator of the mathematical foundation of surface description, right? B-spline surfaces, NURB surfaces, etc. That was invented by this guy. Coons is talking about Ivan Sutherland's Sketchpad. Sketchpad, of course, is considered the first graphical user interface and the first CAD application. So this is really the very beginning of computers as a design aid. What did we just hear? A couple things strike me. First, we might notice that the claims made about the latest technology in 2023 are remarkably similar to those made about the latest technology in 1963. Right? We heard a claim regarding a human and a computer entering into the quote, relationship of, quote, the fullest cooperation, right? This sounds familiar. If we continue listening to the interview, we'll hear another claim about a radical technical leap forward, similar to the one that we're in right now, from a computer acting as a, quote, very elaborate calculating machine, sounds dumb, to like functioning almost like a human assistant, sounds much better, right? So each of these claims finds echoes, obviously, I think, in our current climate. A climate of, really frankly, overhyped AI-assisted augmented automated design. Might things be different this time? Maybe. The other thing we might notice is that CAD, as it developed from 1963 to 2023, has not worked out as advertised. Right? The initial promise of computation as a, quote, partner in design has not been fulfilled. It's not what's on our desktops. Why is this? To me, it's because our current computer-aided design systems impose certain rigid ways of working and thinking that are often not in line with how creative designers actually think. Right? This is true of dumb CAD and smart CAD a lot. This is dumb CAD, right? But actually, the more advanced a piece of software is, let's take Grasshopper, the more acute the problem can be. Right? Grasshopper is far more insistent that we adopt its way of thinking, linear, rational, right, step by step, than say vanilla Rhino, right? But really, they're both a problem in the design process. So it seems to me that prevailing approaches to CAD software have been fashioned to support really modes of reasoning that are of only secondary importance to design activity. What do I mean by the wrong modes of reasoning? Well, as Andrew stated so clearly this morning, few tools have focused on expanding our imagination, and they've been doing kind of other things itself, right? Other things entirely. To be an expert user of really any technological system forces us to accept the assumptions that underpin it. And at this moment, we have sort of the wrong assumptions. We have assumptions that are at odds with most of what we want to do as designers. And this is because thinking through words and symbols is different than thinking through drawings and images. And the computers that we use mainly think through symbols. So at the risk of oversimplification, let's just talk about different modes of reasoning associated with these different media. We tend to use symbolic logic, math, numbers, right, addition, components in a Grasshopper model, when we want to be deductive, that is, applying general principles to find specific solutions. We tend to use linguistic logic, speaking to one another, describing, debating, when we want to be inductive, synthesizing specific observations to find general rules. And we tend to use imagistic logic when we want to be abductive, which means imagining possible solutions, giving incomplete or contradictory information, which really is kind of getting to the core of what the design process really is. This often involves, these are important to what we do as we design. Historically, computers are fantastic at that first thing, right? Mostly useless when it comes to the second thing, unless we want to talk about social media or something like that. And they actually present active obstacles when it comes to the third thing. They get in our way. And what gives me some optimism about this moment is that I feel like this might be about to change, that computers might get better at that third thing. ML might finally fulfill one of the original promises of computer-aided design, which is to better align with modes of reasoning that are prevalent and important to design. What makes me think that? Well, ML is fundamentally, to me, an abductive technology. And I think importantly, it's undeniably a cultural technology. It carries with it the weight of the cultures that produced it, as Andrew said in the first talk. And I think unlike traditional CAD systems, which may appear neutral, as Jenny said in the second talk, these systems that we're working with here are clearly cultural. They're trained on other people's data, right? It bears the weight of this sort of cultures that produce them quite clearly, right? Very discernibly. So they're inherently historical and analogical. They are so because they're trained on data derived from the world, and they generate patterns drawn from the world that they're trained on. Further, ML tools are inherently imagistic, and I don't mean like those kinds of images. I mean like about sort of recognition of like patterns and like things it's seen before, right? So they match patterns to other patterns, and the fundamental operation of these kinds of systems is recognition. Finally, ML tools are inherently, well, they position us as curators. They're inherently kind of curatorial. CAD positions us as sort of composers, like a painter, I suppose. Parametric models position us as, what, logicians or something, computer scientists maybe. ML positions us as curators, as selectors, right? And so for this reason, I think we might be on the cusp of the first generation of CAD tools that offer computational support for abductive thinking. And that's genuinely novel, or potentially novel. Put another way, we've spent the past 60 years, since Kuhn's, learning to think more like a machine. Wouldn't it be nice if CAD could think a bit more like us? ML hasn't done this yet, but it offers this possibility, and I'm very optimistic about it. Okay. This is the part where the Acadian people might want a coffee. So as I've mentioned, mirroring the transition that CAD followed from the 1960s to the 1990s, creative ML is moving from the domain of obscure systems, accessible to a small handful of dedicated experimentalists, into a domain that more resembles kind of commercial software and more easily accessible systems. That's an exciting moment for me personally. It's also very dangerous for those of us who advocate for the humanistic applications of technology, but I'll come back to this dangers in the end of the talk. First, I think our conversation about this moment of time would benefit from a short unpacking to the social and technical context that led to it. As I'm sure we're all painfully aware, the software that is used by practicing architects is not made with our discipline in mind, right? It's adapted from tools developed for other contexts, right, that usually make more money for software developers. Usually these are systems that are designed for really larger markets than ours. Most of the time, these technologies kind of seep into our world in a trickle, giving those of us who work in design technology plenty of time to reflect and prepare for what changes this technology transfer kind of might bring. And this is a lot of what I do, holed up in my tiny office in UC Berkeley. At other times, something new like hits us from like a rock from the sky, right? And the summer of 2022 was one of these times. In that summer, we saw an explosion of synthetic architectural images produced by one of any number of a series of text-to-image generation tools that we all know very well. One released after another in a span of just a few months. Dali, Midjourney are well-known, Sable is a bit less known. But my question here is like, what led to this? What led to this particular moment? Despite appearances and the sudden appearance on the scene, diffusion models like this are not sorcery. They are tools produced in a specific socio-technical context, right? They were software made by people. So while the impact of Midjourney and Dolly and Stable might feel like a rock from the sky, the tools themselves are not extraterrestrial in nature. They did not emerge sort of fully formed in the vacuum of space, but rather they're rooted in a particular social context and arose out of a specific technical history. To explain that history, I'll look at 3 moments in time very quickly, probably too quickly, frankly. The middle of last century, the 1950s and 60s, I've touched on this time period once already. The turn of this century, the 2000s, 2010s, and events that took place across maybe an 18-month time span last year. As I talk about these 3 scenes, what should we be looking for? What's the important thing? A lot of text on that slide. So at each period, I'll look specifically at 3 factors. First, the technology itself. So that includes the hard technology, the algorithms, architectures, models, data formats, blah, 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 as well as the domains that this technology arose within. So what domains of application it was meant for. It's like what real-world problems do AI researchers seek to address? Next, the social context in which the tech was produced. So what's supported? So this would include private and public research institutions, informal online communities, social networks, creative collectives, blah, blah, blah. And then finally, I'll look at the infrastructure and access which makes this activity possible. This includes tools, resources, softwares, platforms, etc. Why do we look at these things together? It's because technologies, infrastructures, social structures, creative practice, all of this is intimately interlinked. So there's layers of interdependency at work here that you can only discover by looking at this stuff together, right? Far more intricate layers than I have time to pull back in the space of this talk. Networks and connected circuits to simulate intelligent behavior. Notable among these early models was the concept of the perceptron, which we see being invented here in an actual photograph, which is a classification algorithm which was first invented in 1943 and first implemented as kind of a physical machine in 1958 by Frank Rosenblatt. This early AI research was, of course, far removed from practical application, while its advocates would tell you that it has a whole potential range of applicability to a whole potential range of problems. The work was actually not propelled by this kind of academic general interest alone at all, but rather was supported for its promising applications in national defense in particular. For example, at MIT alone, shown here being covered in money, ARPA, which later became DARPA, contributed $2 to $3 million per year to AI research from 1963 to the mid-70s. And this money was provided with very few strings attached and contributed what has ended up being termed the kind of technological libertine atmosphere at MIT, an atmosphere that's strongly related to what we now understand as hacker culture. So I'm highlighting the perceptron here, just spoiler, because it's not only is it the great-grandfather of modern machine learning systems, it also figures large at both this kind of start and end of this initial period of AI, as connectionism was abandoned in favor of symbolic reasoning approaches, which is like a different approach. It turns out that connectionism is but one school of thought in AI research, and there are others. So the shift away from connectionism to other forms contributed to the first of two, or what are called AI winters. These are periods of diminished progress in AI. They're kind of quiet periods. They have less to do with the natural progression of technological advances and more to do with AI's, quote, visibility or invisibility. There's like cycles of public and private investment that are really driven by popular interest and the expectations of marketable outcomes. Okay, I'll just move on from there to the quick summary. I'm mainly summarizing this period as to help us compare it to the future periods. So in terms of technologies, a set of technologies were developed in this time that formed the foundations of the connectionist approach, aka neural networks. They were done so for particular reasons, right? So people were looking at applications of machine translation, natural language, reasoning and search, etc. And most of these had applications to national defense. In terms of social contexts, all of this was taking place at academic labs at R1 research universities. Funding was dominated by government grants, often military-related, and with very limited private money. This had an impact on the infrastructures and access. So, like, what I'm looking for here is who has access to resources necessary to use the technology or make contributions. Obviously, this is all very expensive stuff, and it's limited to a small group. So, we now jump forward 50 years to the early 2000s and 2010s, leaving aside a huge, unexclusively large a body of important history in the interest of a relatively short presentation. So suffice to say that the AI winter of the 1970s led to an AI summer in the 80s, which propelled, among other things, by an infusion of cash by the Japanese government, which was followed by a second winter in the 90s, and oh my god. But the most recent thaw really could be traced back to this time, to scene 2. Of course, none of this technological development occurred in a vacuum. Lots of things changed across this 50-year span, and there were 2 major changes that are relevant to this discussion. Number one, computers got a lot faster during that time, both in terms of general processing and also dedicated graphic processing, GPUs, right? Number 2, the world started producing and storing vastly more data. Both of these are very important for the connectionist approach to AI to flourish. The second point is really the crux. Across the first decades of our current century, access to large amounts of data and cheaper computers to store and process this data radically transformed the global economy. The expansion of computing power and resources, of course, is not just an opportunity, it's also a big problem. To get a sense of the scope or the scale of that problem, in 1997, dot on the left, computer scientist Michael Lesk estimated that there were, quote, a few thousand petabytes of information in the world. He's not talking about information stored on computers, he's talking about information in the world, the contents of every library, right? All human knowledge, he estimated to be a few thousand petabytes. In 2011, the middle dot, McKinsey Global Institute estimated that there was 13 exabytes of new data, so 3 billion gigabytes in the left, 13 billion gigabytes in the middle, 13 exabytes being created and stored by companies and consumers every year, right? So the first thing is a in-the-world estimate, the second thing is a per-year estimate, right? The volume of the data produced today is hard to quantify. Let's take 2021 numbers, which are estimated to be around 94 zettabytes. A zettabyte, I don't remember, it's 94,000 billion gigabytes, right? Estimated per year, hard to get a handle on. So this phenomenon was known in the early 2010s as big data. I think we all remember that moment in time. It had an impact on our discipline. Deep learning, the neural networks that we use to make these images on the wall, was a technology developed to deal with the problem of big data, right? Not just the opportunity of big data, the problem of big data. So this is a well-known and well-studied story. It involves a transition from scene 1, technologies that were propelled by the need to address wartime logistical problems, right, to scene 2, transitioning to technologies propelled by the needs of governments and private interests to more effectively sift through a steadily increasing volume of data about, frankly, us, right? So that is to say a transition of technology from technologies of war to technologies of mass surveillance. So the problem of big data and the perceived opportunities for surveillance and commerce provided with the motivation and justification for the technological innovations and the new funding structures of this period which propel us to today. Right? So these in turn, of course, set the stage for the period that we're in now. Quick summary to help us compare to future contexts. Technologies, so a range of technologies are being quietly developed in the 80s and 90s that refine and extend neural networks that enable the kind of widespread application of different forms of ML to practical problems. So these include things you might have heard of, convolutional neural networks, backpropagation, autoencoders, etc. To support this development, the infrastructure has also moved along. A number of important infrastructural pieces were needed. On the one hand, foundational data sets that are still used today to support machine learning research were defined, were established, and in relationship to kind of like newly identified domains of application. So the first like large handwriting data set was developed here, the first language data set, etc. Further, the foundation of what we now call kind of cloud infrastructure, this has been established during this time, which makes high performance GPUs and compute power accessible. Amazon Web Services starts at this time, Google Cloud Platform, etc., etc. In terms of application domains, the problems of this period were really valued for their commercial application in sifting through large amounts of data, as I've said. Image search, handwriting translation, Google search, all of these things are kind of established in this moment. But they're also valued for their visibility and their marketing for the tech firms that develop them. And I think this is an important piece that we often overlook. This stuff makes the work of certain firms very visible to the public. It was the same in the 2010s. So think about like when Deep Blue beat Garry Kasparov in chess, or when AlphaGo beat Lisa Dole in Go. We think about DeepMind, we think about IBM, right? So all of these events are intended to shape public perception around the technology. Social context, what are the organizational structures that support these developments? This looks a little different than the previous period. So academic, this is kind of what you would expect, right? Academic research labs
are established, expanded, and proliferated across this time. Oxford, Stanford, MIT, everyone's got an AI lab now, right? Private research labs are now also being established. So big tech firms like Google and Microsoft are developing dedicated AI research groups, and this is happening for the first time in that moment. And much of this is propelled by a revival of government funding, which still provides the bulk of support for basic AI research in academic settings. So we also see the beginnings of kind of like private backing of ambitious, like moonshot, quote unquote, moonshot AI interests are happening at this moment. The talk doesn't do enough of this, but just as a way of transitioning to the final scene, it's hard to believe I'm talking about kind of creative ML and the infrastructure of the technologies. I haven't mentioned anything that's going on in the creative world yet. I just want to kind of mention that GANs and Deep Dream are happening like in between these two periods, and these are well known in the ML community, perhaps to this community as well, I'm not sure, and they have a huge impact technically and culturally within a small kind of group of practitioners. These things really drove generative aesthetics from the 2015s to the 2020s, and like where I began to get interested in this work, and enabled a range of important artists, I should say. Okay, scene 3. We could say that this current springtime that we enjoy, AI spring that we're in, began in January of 2021 with a series of events that brought us Midjourney and all the rest. This came about because of a specific social and technological context that I've described in the previous two scenes, but it's really marked by a level of accessibility to technologies that drive these tools that is nearly unprecedented. So in the intervening like 5 or 10 years, emphasis has shifted from sort of basic theory to applications, from developments in foundational sort of technologies to developments in infrastructures that allow access to those technologies, right? So the establishment of those infrastructures hold deep, important impact on the social production of creative work and have enabled everything that we're seeing in the room today. The infrastructures I'm talking about are like the availability of published models, the availability of like an open source architecture for like producing this kind of thing, open source of the weights of these models, access to compute, etc. So all of this is enable non-affiliated folks, quote, quote, non-affiliated folks, like smaller scales of production, casual technologists. All of these things are kind of new, and they're making real contributions that hold wide impact. And this is when we finally meet our protagonists of the story, which is a text-to-image generation systems that are developed at this time. So the tools that we use now, and that sparked the kind of deluge of synthetic images in summer 2022, these are a direct product of a series of specific technical innovations that take place in an unexpected social context that's done by like unexpected folks within about an 18-month period. And a lot of this is enabled by these kind of non-affiliated labs. I think I'll just kind of skip over this. But I really want to get to the star of the show, which is this, clip-guided diffusion. If you're not aware, that's the name, the kind of formal name for the technology that drives all of the image generation stuff that we're working with. It's changes here and there, but this is close enough. So I want to kind of dissect this technology, kind of take it apart and do a biography of its components and like tell you like where it came from, right? Kind of describe its lineage. So the core technical elements to these kind of contemporary tools are right there in the name of the technology, clip-guided diffusion. This is an amalgam of two systems, actually, right? On the one hand, you have diffusion, which is responsible for the composing of synthetic images. It's the thing that Andrew described as learning how to get from noise to images that we recognize, right? Diffusion was developed between 2015 and 2020, primarily in academic labs, specifically Stanford and UC Berkeley, go Bears, in a fairly kind of open source manner as these labs tend to proceed. On the other hand, you have clip-guided diffusion. Clip is responsible for guiding the diffusion process towards an image that matches a given text prompt, right? So clip was developed in 2021 by a private research lab, OpenAI, and OpenAI released both the architecture of clip, that's the blueprints, as well as the weights for the model, that's kind of like delivering the engine itself, in like January 2021. They didn't release what they trained the thing on, they didn't release the data set, but they released the working thing and the blueprints. This release in January of 2021 was a hugely pivotal moment in the history of this stuff. Neither clip nor diffusion were the kind of the, quote, first of their kind systems. They were not like the first thing to do these things. But really we could say modern approaches to text-to-image synthesis started in 2016. This combination of stuff was the first to find real success
A success that was only found after a series of experiments that discovered the kind of sort of magical combination that really worked. I'm going to walk us through a few of these. So the beginning of this is OpenAI releasing this thing called Clip, right? And then people start playing with it. And all of these little dots along the timeline are small-scale experimental technologists, often artists, that are messing around with combining this technology in different ways with other technologies to do things. So I'm going to show you kind of a history of what this looked like in January 2021. Like, that's the kind of thing that you would get out of one of these systems. This is a year and a half before I think Midjourney was released publicly. So this is Siren plus Clip. It didn't really get a name besides that. This is the first person to connect Clip to an image generation function, not diffusion, something else. His name is Ryan Murdoch. He's a self-taught ML engineer. He's not trained in machine learning. He has a bachelor's of psychology from the University of Utah. And his work was important. He also later joined Adobe to work on neural filters, which I think are coming soon or already out in Photoshop. So no diffusion here. He uses something called Siren as the generative model. He also released something called Big GAN plus Clip. This was the first time that Clip was connected to a GAN. Also Ryan Murdoch, I'm going to go kind of quickly through these. He also made this thing called Aleph to Image. This was a dead end. We didn't kind of go anywhere after this, but it was another kind of experiment that put things together. Here he's taking apart DALL-E, which is another OpenAI product, and using only the image generation part to make images. This was a pivotal invention. This is Catherine Grossman, who put together VQ-GAN, another GAN plus Clip. So we're still not at diffusion yet in June of 2021. This is one of the most widely forked, like something plus Clip image generation systems out there. And there's a huge list of forks elsewhere. And something which really made the biggest cultural difference was the release of what's called Disco Diffusion. And Disco Diffusion is kind of the immediate predecessor to things like Midjourney. It came out in October. That is the thing that made that, and it's really a kind of community of amateur artists, are all artists amateur? I'm not sure. That very online artists who were interested in making like that kind of thing that really iteratively sort of refined the technology and got it 90% of the way to where these larger companies are using it. So, in summary, in 2011, some people released a bunch of collab notebooks that make psychedelic art in clever ways. Why is this important? It turns out that all the text-to-image tools that made a big splash in our world and are like on the walls today and led to symposia like this one, DALL-E 2, Midjourney, Stable Diffusion, ImageJet, all of them are a direct product of these kind of, quote, clever little tricks developed by artists, right? Amateur artists with no formal training, passing around collab notebooks, collaborating on Discord, on Reddit, etc. So seeing this recent history of technical innovation and I suppose artistic innovation through the lens of our analytical framework, we can clearly see what makes this current moment so distinct. I've already talked about the specific technologies here, developed recently that's going to catalyze this burst of interest. Clip, diffusion, GANs, all of these things are important. I've also already described the infrastructure that enabled widespread access required to make these kinds of advances. So Google Colab and GitHub were important elements for distribution. The cloud infrastructure that was developed in the last scene, that's important for access to compute. Discord was used, other kinds of social networks were used for kind of collaboration, online bragging. These are all need to be in place in order for this invention to occur. The social context in which these advances took place were largely established in the previous time period, but they're worth emphasizing just one more time. We find the usual kind of institutional players here. So big tech labs like Google and OpenAI are important. They release some aspects of the technology, but so are academic institutions like Berkeley, LMU Munich, Stanford, etc. We also find kind of independent labs. I skipped over that part, but there's like kind of these nonprofit, community-driven efforts like eLuther AI and Stability AI when it began. They were important players here as well, as was, and I think this is kind of my larger point, many important contributions were made for and by creative communities of kind of amateur practitioners, such as the case of Disco Diffusion. So, thanks for your indulgence there. So if you take away just one thing from this kind of rather dense story, with this rather dense history, I hope it's this. We live in very exciting times, right? And creative machine learning has never been more accessible. It's accessible in ways that it never has been before. In the very recent past, like big, important contributions have been made not only by large institutional players that you might expect, like the Googles and OpenAIs of the world, but also communities of creative practitioners that are really not so different than the people in this room. And so even as this technology transfers from the kind of domain of experimentation and small-scale sort of use to commercial software, I think we can keep in mind that it's still very possible for people like us to engage in deep and important ways, and not just to kind of accept it as a piece of software. So as you can see, I personally feel this is a very exciting moment for computational design and for creative machine learning. But I also can see that this is a dangerous time for those of us who advocate for the humanistic applications of technology. So the conversation, of course, would not be complete without a frank discussion of the risks. What are those risks? I'll frame this maybe in terms of 3 questions for the panel. First, might AI wreck existing cultures and scenes in design? I think this is one of the major anxieties in the fine art world, is that existing kind of cultures, sometimes connected online, sometimes very much in person, might be disrupted by this. These are things that are, of course, constantly changing in dynamic fields like architecture, but it remains unclear which sets of sets of communities might benefit from this kind of change and which would not benefit. In a related note, might AI, right now, produce a shift in the centers of power in design? And if so, what way? Architects, of course, are part of a broader network of social, technical, financial, and cultural exchange networks, alongside clients and contractors, developers, a multitude of publics and constituents. In this context, we have to ask, who profits, right? Architectural work is already beset by inequities and exploitation. In what ways might this make things worse? Finally, and I think also related, might AI devalue certain aspects of the craft of design? Text-to-image is a kind of classically disruptive technology. It's unsurprising that it's coming out of Silicon Valley. And all of these kind of disruptive technologies have winners and losers, right? Those who make their living from architectural visualization, for example, may not be so excited about the lowering of barriers to make architectural visualizations. I think it's worth noting that typically in this kind of world, the winners tend to be tech-savvy and the losers do not. This was the case in the rise of like parametricism, I can use that word, in the early 2010s. I benefited personally from an architect who knows their way around the computer from that particular moment in time. I was valued as an outgoing graduate of a program, right? So the dynamics here are a bit different, right? Because these tools are nothing else but accessible. So it's not like it privileges a particular technical subset of people. Maybe it privileges the literate, right? People with good vocabularies, or who know good synonyms for things. So to illustrate this point, like, we could look around the room, and it's filled with compelling and imaginative images, each of which was made in seconds. My final point is, if there's any economists in the room, what happens when a product becomes much easier to produce? First thing that happens is the market experiences a surplus. We have a lot more of that thing. And the second thing that happens is the product gets cheaper. It's devalued. So I think we're entering a phase in which architectural image making is easy, it's cheap, it's quick, and potentially holds radically less value than it has in the past. And so I think the question remains how this sort of flood of both incredibly beautiful and radically cheap images change our discipline. Thank you. speaker, Marta Novak. Marta Novak is ChatGPT, Marta Novak is the founding principal of Anonymous and holds several high-profile positions, including Senior Innovation Manager at Google R&D, Digital Fabrication Assistant Professor of Architecture at the Knowlton School of Architecture at Ohio State University. She has worked for top architecture firms and has been widely recognized for artistic and architectural work, including exhibitions at the MoMA Museum and Harvard University. Marta has received numerous grants and scholarships and has presented her work at international conferences, including the World Economic Forum. She has taught architecture at several universities, including UCLA and Northeastern University, and holds degrees in studio arts and architecture from St. Catherine University and Harvard University. Please welcome Marta.
Thank you for having me here today. All right, I'll just jump in. I promise I only have 4 slides of history, and I will show you my projects. Well, history of modernity is tied to the emergence of mechanization and the ways in which human and animal labor has been gradually replaced by machines. From the very beginning, this simple machine's desire was not just to imitate basic human or animal functions like to walk, talk, play music, digest, or defecate, but also, or ultimately, to process information or to think. For example, here, the mechanical Turk, or automation chess player, was an automatic chess-playing machine constructed in the late 18th century. The machine was built by Wolfgang van Compellen and was able to play a game of chess against a human opponent and win each and every time. But the Turk was in fact a mechanical illusion that allowed a human chess master to hide inside and operate the machine. With a skilled operator, the Turk won most of the games played during the demonstrations around Europe and America for nearly 84 years, playing and defeating many challengers, including Napoleon and Benjamin Franklin. The idea of a machine that could think for itself couldn't deliver at that time on its premise, but the desire for that premise was already there. It is until the Deep Blue was invented as a chess-playing expert system run on IBM supercomputer, where the first use of artificial intelligence was applied. It played in 1996 as a first match against world champion Garry Kasparov, but Deep Blue lost 4-2. It took a series of upgrades, so a year later, in 1997, Deep Blue finally won 3 games against 1 draw in the rematch. Today, machines have entered all aspects of our daily life, not only with superhuman abilities, but also with different types of intelligence. One of these aspects is movement and its behavior in space. To me, what's important is to understand how these intelligent machines behave in space and therefore move autonomously. In the studio I taught with Greg Lynn, we simulated different robots' behavior in space. Path they occupy, and we see the conceptual differences of movement between a Roomba, here on the right side, that builds modules within the space, Jita robots in the middle, that follows humans, or a Starship robot all the way on the left side, that finds the shortest path from point A to point B. But we also investigated machine vision and learned to understand how this machine sees space and understand depth, see obstacles, as well as to recognize objects, especially architectural features such as large architecture. With the understanding of these technologies, in my seminar we built one-to-one scale mockups to test our assumptions. Here in a table, allowing both of them to throw garbage when the trash can arrives at their location and moves in between them, serving them at different intervals. A little choppy, but still. Or another example with this intelligent chair, where we tested a chair that follows a person with the use of machine vision, with the use of different cameras and recognition, where, for example, here with the use of the camera, the robot can detect a person that is seized in front of it. It can count. It has the ability to count number of people in space, and with the depth camera, it is able to see the distance of the person that it follows, but also take certain information such as the surface that it will be moving on. It has the ability to see the gesture recognition and understand what it needs to follow. And of course, we can test these with our little turtle bot, learn the environment that is moving on, and interestingly enough, also predict the certain actions. So, for example, if Zoe is going to the refrigerator and then to the microwave, the chair predicts that the next thing is to move toward the table because it's dinner time. So it automatically goes toward the dinner table and waits for the human to arrive. We tested different things with SLAM in our Ideas Studio and ran the chair on its own, thinking about its different configurations of the chairs being able to assemble on its own. All of these were the attempts to rethink the components of architecture as intelligence objects that participate and interact in our daily lives. During that time, I was also able to work on a project with the City Lab to rethink NASA JPL offices, and we designed the Intelligent Office Rover as an individual pod that in turn could completely transform an interior of their space. This interest of the interior office and automation led me to Google R&D for the built environment, where I led numerous projects. Today I'm not at the liberty to share all of them, but I will share a few, and I hope it will give you a good glimpse of what we do at the lab. I play a video. I hope you can hear it.
So it's not just open office, it's not just enclosed office. It's actually a flexible hybrid between the two.
Michelle Kaufman's team created a new model. Google employees will get a menu of options rather than the same daily desk. The philosophy here is to keep it light and ready to change, like making rooms quickly out of inexpensive building blocks.
So things like these panels that we call pixels, they're like Lego pieces.
I love it. You can have things set up for common the whole room.
Exactly.
They're building plumbing, electrical into the Lego pieces. The kitchen remodel at home is months of work.
So this kitchen takes 2 people, 2 days to put together.
Nothing is off the table. Google's trying inflatable room dividers, even a campground concept for working outside in the summer. And Kaufman says none of this is permanent.
Did it work well for the remote participants? Did it work well for the people who were together physically?
One of the hardest problems, trying to keep remote workers from fading into the background. Here, you can't ignore these people.
Exactly. Where they all have the same level of presence in the room. The cameras are set up that even in their experience of joining remotely, they're able to also see everyone equally.
It takes a team of people. I interviewed Javier Soltero this morning.
You have to find a way to create the places, even if they're digital ones, where people can feel like they're present and are able to collaborate.
And if some of the best paid, most valuable employees in the world say that they don't want to come in, what do?
So you have to task the time to figure out a way to create other spaces, physical and virtual, where more of that interaction can take place, even in unstructured time, so that you can capture as much of that sense of connection across people as possible.
Google R&D Lab focuses on the projects that are future forward and will be deployed in our offices in the next 10 years. We want to prepare for the future and make sure that we have the time to deploy and develop technology that can be deployed in as a solution at scale. We always start with prototyping, so what we're looking at are a series of very first round of rough prototypes, really concepts that test the core function, not the form. All of our project go through intensive and rigorous rounds of prototyping and user testing. The idea is that human scale and team-based innovations in workplace products and design strategy will allow the teams to be more productive, collaborative, and healthy. And in addition, our real estate will become more efficient and sustainable. And just to give you a sense, Google has offices in 170 cities in 60 countries, which totals in about 2,000 buildings. There are many projects that we explored as part of our future thinking. One example would be a project that is called the Team Pod, and it's an idea for a space around the teams instead of a space around desks. Because in the future we'll no longer have an open office or nor cubicles. It's a space that the team can quickly change, reconfigure, and adopt the needs of the team. With Google Workforce, with over 150,000 employees all over the world, face-to-face collaboration is often impossible. So to deal with unexpected blend of remote and office workers, we prototyped this new meeting room called Campfire, where in-person attendees sit in a circle intercepted with impossible to ignore large vertical displays. So instead of, you have to imagine, instead of like in a Zoom, you usually see very small tiles of remote participants. Here, everyone who is joining remotely gets one display, so one display per person, and it sits on the same footing as those that are physically present. Here, we want to make sure to give remote participants equal representation and align gaze to facilitate face-to-face conversation. A task that may seem simple, but actually incredibly difficult right now without further development of next generation and AI-driven technology. The teams, individual work patterns become more hybrid. And for those who no longer, we build a prototype desk that intelligently adjusts to employees' personal performance and ergonomic needs with a swipe of a work badge. A handy feature for workers who don't have a sign desk because they only drop into the office once in a while. It calibrates the desk. It knows your heights and tilts the monitor. It brings up your family photos on a display and even adjusts the light to the temperature and color hue that you like. And final project, with the flexible thermal comfort project, HVAC system, and please in this photo pay attention to the duct system at the top. So this very two duct sticking out, not the little wooden top. The photographer who was photographing this project didn't really know what to pay attention to. We were able to sense and control individual workspaces, provide desirable thermal comfort to the employees that are in the office instead of heating and cooling the entire space. With this strategy, we're aiming to lower our energy use and carbon emission. This would not be possible without an individual, intelligent, localized system as well as distributed infrastructure that would control the data set and send the right amount of air conditioning to the right corner in the office. Some of our initiatives are concerned with ideas around flexible, lightweight, and autonomous partitions. And this is the research that we did in collaboration with Ohio State University and the lab, where the students imagine different types of robotic walls that with the small robot can come to you and provide privacy. With extensive research on different types of materials and techniques, some of our research would lead us to investigate these like ultra light materials and partitions that would occupy unusual space. So usually we would consider to deploy our projects on the ground or on the ceiling, but here they are occupying the space in between. So the idea was to create a flying partition, and here's a proof of concept of the autonomously flying partition that and move through space. I will just maybe through different type of movement and mechanism using smaller motors and flapping mechanisms. Incredibly difficult and challenging project that after this rough proof of concept we abandoned for many reasons, but especially with crazy HVAC blowing in the space that was moving the balloons, it came to be very challenging, but at the same time very fun to experiment with. All right, and the last project I'd like to share today is called the balloon wall. And I think it's the one that brings all the components that I mentioned today into one. The idea is inspired by the butler and the party wall. Because the butler, it comes when it's needed, it shows up and disappears, yields when to people when they see them, stops and give way. But the party wall has the ability to convert the existing room. Meanwhile, majority of unplanned meetings in an open office occur on the office floor rather than meeting rooms. The open office is not usually equipped to support such a spontaneous event. The balloon wall is an example of autonomous furniture that could be deployed on request in the open office. And it provides a microspace within a macro space of an open floor. In order for us to understand how we would deploy it, we had to understand how people move and behave in the same space. So we organized a schedule around how people work in a floor plan, coming in and out and going around their daily routines. So the engineers, their shifts, where would they be moving between their conference rooms, amenity spaces, phone booths, team discussion, and so on. And then with the simulation, we were able to understand most of the occupants of the space with people. And we wanted to make sure to then deploy the use of the robot within the spaces that were mostly on the blue position to not collide with people too much. And with that, we were able to then deploy SLAM and run autonomously navigation. And with machine vision and depth camera, able to use that for obstacle recognition and recognize objects if needed. Again, rough testing and prototyping was part of the process to evaluate mobility, maneuvering, rotation in place, expansion, and ability to integrate a whiteboard. Some of the prototypes were taking a lot of space, even if they were much simpler, so the idea of making it more compact was the kind of a form that we had to move forward for the final project. So the final prototype moves autonomously, moves through space, and relies solely on machine vision through the use of simultaneous localization and mapping and a turtle bot. SLAM allows the robot to construct a map of the environment while moving and simultaneously localize itself within the map, navigate and avoid obstacles. It also makes new decisions as it encounters and discovers new obstacles within the floor plate. For example, somebody putting a backpack on the ground that wasn't there before. And once it arrives at the location, it can use its mobility to expand and then inflate in order to divide and enclose the space. It is made out of an iridescent, fully biodegradable membrane as the commitment to use healthy materials. The membrane allows light to come through, yet it provides visual transparency as information and detail won't be coming through. And this mobile furniture solution shows the potential of creating more dynamic and reactive interior spaces. At the end, there is a tendency to use AI to supplement a natural human intelligence and to use it so it functions as a designer. But once the buildings are designed, there is nothing left to be done except to generate another image, building, or space. But what I'm interested in is to give artificial intelligence to objects, architectural components, and buildings, and allow them to continually interact and respond to their human users. Not to create intelligently designed spaces, but to rather create real intelligent space. Thank you.
Okay, Sophia, I don't know if you can hear me, but you can share your screen now. Hey.
Hello. Yeah, I'm going to share my screen now.
Okay, Daniel will introduce you as well, but we can hear you.
Okay, great.
Hi, Sophia. Can you see us?
Yes, I can.
Yeah. Thanks for joining us. So I'm shortly reading your CV or introducing you. So please welcome Sophia Crespo and her working partner Felicia McCormick. Too many CVs. Felicia McCormick and Sophia Crespo share the studio practice of entangled others. Their work focuses on ecology, nature, and generative arts, with emphasis on giving the more than human new forms of presence and life in digital space. This involves exploring questions of relationship, biodiversity, and awareness through biological inspired technologies. In turn, they highlight how through conscious efforts, new technology can be used to bring attention and awareness to the unseen that we are tightly interwoven with. Entanglement is a complex state, one where no single entity can be said to be separate or somehow unaffected by any other person entangled. We cannot consider ourselves without others, act without interacting, speak without being heard. Please welcome Sophia Crespo and Felicia McCormick.
Oh, sorry, Sophia, I think you're muted.
Sophia, muted. Hello, everyone. We're in, I think, some technical bit. Yeah, so we're an artist duo, which we work primarily with a focus on the modern human world, or natural world. So this has come from a few different sources for us, personally, and the Sophia began with the microscope, which you'll learn a little bit more about here.
Yeah, so I wanted to start with this picture of my first microscope, actually, which I got as a present for Christmas when I was a kid. And the reason why I wanted to show this is because I'm completely fascinated by microscopes. There's something which I find really correlates very well with the use of AI we have right now. And that's because this is a tool, you could say it's a technology that allows us to see something that is there, but that isn't visible to the naked eye necessarily. And this is an example of vitamin C crystals, for example, that I've been looking at not without a microscope, but with another one. I have many. And in a way, AI, to me and to us, it's a tool that allows us to extract patterns and rearrange them. So we see AI as a technology that is specifically kind of a pattern extraction engine. And it's very important for us as artists to demystify AI, to not attribute magic connotations to it, to really step aside from that and purely see it as a tool that we can use to achieve a certain result. Now, in this process, this is a personal part of the process, I was influenced by an experience I had, again, during my childhood, where I encountered a virtual jellyfish at an aquarium with a 3D display after me. And later on in life, I found myself wanting to make art really inspired by the textures of jellyfish. And I couldn't figure out why. Maybe it was a way of exposure therapy. But I just, through the use of AI, it made me feel like there was a kind of process within a process. It made me question my own cognition in a way. It made me think like, okay, I've been exposed to this experience, and now I'm inspired to use it as a starting point to make art. And simultaneously, I'm creating a data set and using this tool that extracts patterns from that and creates new variations of that for me. So these are some of my early examples, my early pieces, which, to be honest, like the original ones were in much lower resolution. I started working on this series called Neural Zoo in 2018. And we didn't have the tools that we have today or the computational power that we have today. Not because it didn't exist, but just because it wasn't available to us in the way that it is now. And it was a lot more painful. As a non-engineering person, I had to learn a lot of things about how to connect to a remote machine, and I had to learn a lot of engineering stuff just to be able to do them.
Yeah, so what you're seeing here are clearly jellyfish. However, naturally, all of these have been generated with a generative adversarial network, or a GAN. And the interesting about this is that when we take a data set of images and train a neural network on them, for us, and this is of course a gross oversimplification, but as we are not engineers, we like to take creative liberties, that there is a form of visual distillation happening here. So the essential patterns and features that extract from the original data sets become what the model has learned. In this case, these are clearly visibly jellyfish, right? But if you actually start to examine the jellyfish itself, what you see here is actually just one stage of the jellyfish life cycle, a life cycle that actually contains over 7 distinct different stages, which are visually very different from this. But because the only available data when we trained this model was only of this Medusa stage, what we actually have here is more a representation of what we commonly understand or associate with the jellyfish rather than what a jellyfish is in itself. So while this is very useful, it's at the same time quite misleading. So we tried with this project here, Chimerical Stories, to use genetic approaches to crossbreeding neural networks between of butterflies and of jellyfish, not as a means of trying to recreate accurately the jellyfish life cycle, but rather as a means to explore ways of trying to tell the story about the far less commonly known, but far more complex metamorphic life cycle.
Now, while this might look like very crisp or glamorous from the outside, the reality is that our work involves a lot of waiting sometimes, and involves a lot of debugging, and very often this is what it looks like. This might look like nothing, but it's a neural network just running inference over and over, and kind of showing us that well, this is what Kelly and I want it to look like. Means that it's running and that it's working. But to kind of summarize what we were sharing before, this is kind of the loop that happens in our work. It starts with an input that can be a data set that we create, or that we collage, or that we source from, sometimes from an institution. It can have many origins. And then it goes to a neural network. We don't have one specific architecture that we work with. We have tried to experiment with different tools throughout the years. And then that leads to an output, which is an exploration of what patterns were learned by the neural net and what is more prominent there. And then sometimes that leads to tweaking the data set again and training again. Sometimes that leads to the output feeding back as input, so it becomes a feedback loop. Or sometimes that leads to dumping the project completely and starting all over from scratch. But the way we try to think about it is as a meditation, as a process that it has a lot of repetitive tasks in it, but there's kind of a meditative thing about it. And part of this meditation is very often creating our own data sets. That is sometimes like a very hard part because it involves going physically into the water or taking an aquatic drone. We're both very fascinated with aquatic organisms. So so we have, like in a few examples, we've taken even a hydrophone onto the water to record sounds and used aquatic sensors to record data. So this is something that we're constantly trying to push and explore with, but we think that neural networks wouldn't do anything without data, right? Starting to think about the data set is a crucial part of us that come from the field of artificial life. See it because it had its peak or its golden years for software artificial life, at least during the 80s to beginning of the 90s. And two artists who I'm extremely inspired by are William Latham and Carl Sims. Something that is fascinating about their work is that they invested a lot of time and effort to creating their own algorithms to work with, and this often involved a lot of research and collaboration. Particularly with Carl Sims' work here, it involved virtual creatures, is a whole like physics simulated environment, and was run what at the time was called a supercomputer, which no longer fits the definition of a supercomputer today. So that kind of helps illustrate how quickly all the terms in technology are changing with time, and there's no such thing as a kind of fixed terminology that will that can stay valid throughout time. Now, another inspiration, which is completely not software-based, is the work by Luigi Serafini, the colleague Serafinianus. Now, to me, even though there is no AI in this, I can see very well how this feels like a pre-AI piece in a way. I know AI had already been used back then and existed, but there's something that I like very much about it is that this is a project that looks like it has a very clear interpretation. As soon as we see it, we think, oh, I can read this, or I can make sense of what this is, but when we look closer, it kind of, all that meaning vanishes, and we're left with all these amalgams of plants or people growing out of some kind of weird creature, and yeah, all these strange arrangements. So this led to a series called Artificial Natural History, where I wanted to actually use all the illustrations from like early naturalist expeditions, where people illustrated life forms, and I wanted to create new variations of those to kind of think what would be a parallel natural history, what would be these kind of creatures that could potentially have existed. Now, unfortunately, there's a limit to that speculation because I'm using the past as a source. Now, again, the data is extremely important and it always helps shape the result. But it's a process that I deeply enjoyed doing. And another thing that is personally really meaningful to me is the process of merging high-tech with low-tech, or new technology with an old technology. And in this case, I chose the cyanotype as a printing method, which was greatly pioneered by Anna Atkins. She was the first person to publish a book about photography in the 1900s, and what I love about that is that she was researching algae. So yeah, she was like the first person to take these kind of photographic impressions of algae and publish a book with it. And I felt like it was a deeply meaningful kind of technique to use in the context of this work. Now, Feli, if you'd like to jump in here.
Yeah, so when we first started collaborating, we have been working a lot on neural zoo with these speculative creatures. But one of the early things we discussed was how could we extend this into 3 dimensions to not just create images of creatures or to explore these early stages of how cyanotype was used as a means of recording before the camera took hold, or the tradition of botanical illustration. But how could we try and explore an entire speculative study? And what we did over time, and this is going back to honestly, was very little of. So a lot of our work has been about how do you process this data in ways in order to actually be able to generate something inspectile. And this led to this project here, Artificial Remnants, which has taken many forms now and has been a project that's gradually evolved from these early specimens to further bit now, but basically involved us using the little openly available data of insects, training neural networks that can generate 3D and more coaxing neural networks that can 2D into 3D. And from there, exploring ways of generating not just their form, but their texture, anatomical descriptions from language models trained on corpus of text about insects research, their names, but also even their sound in certain contexts. And this has become a series now that explores over several generations from their initial very crude iterations to their now far more complex and refined generations now, these creatures, and tries to form a speculative study of sorts of life forms that didn't exist, not really in order to try and somehow replace nature or ours compete, because you frankly can never generate an insect that doesn't get completely knocked off stage by the sheer diversity and variety and creativity and natural selection out there. But what we can do is use these as a way of mapping the data we have available to us about the insectile world, in this case very little, but still within just that tiny fragment of the insectile, we still find so much fantastic and curious forms to explore.
At some point, oh yeah, sorry, Phil, you can.
No, please go ahead.
at some point we felt like we wanted to step out of generating a single specimen, and we actually wanted to talk about relationship between organisms and to look at something at a higher, a more embarking perspective. So we decided to take the coral reef as an example for this. Now, as soon as we decided to embark in this project, we realized that there is very little 3D data available about coral reef organisms. Not just coral reef, but in general, aquatic organisms. One of the reasons for this is 3D scanning underwater is really technically very, very difficult to do. Light travels very different underwater. And so we were met with the issue of not having enough representation, not having enough data to do this project. So we partnered up with a fellow artist, Joel Simon, and he developed a genetic algorithm to grow 3D coral. And we felt like this was a great way of kind of including this lack of data in our artistic statement, right? So it's like we're embracing our limitation. AI engineers have seen this project and asked, why the hell would you even want to generate artificial data to train an AI to talk about how little data you have? But to us, it makes perfect sense to do that. So yeah, this project is called Beneath the Neural Waves. We have exhibited in many different settings, but one of the ones I like the most is actually 3D printed as polyjet prints. In this case, this is from an exhibition in Shanghai, in China, last year. Ali?
In this project here, Sediment Nodes, so a lot of our work comes from exploring the natural world and finding ways to try and communicate some of these experiences in ways that we hope can also, connect us back to the modern human world. So we see these technologies as a way of, thanks to these distillation-like qualities, as a way of concentrating and helping, bring out facets of the modern human world that we find to be, important, interesting, beautiful, or just fascinating on so many levels. With this project, Sediment Nodes, we wanted to try and touch upon a very personal experience, which comes, from diving and collecting data sets. And with this, we tried to find ways of actually, recreating some of that wonderment you feel that when you dive in sediment-laden waters where the visibility is poor and everything has this rather dull grey quality to it. But if you then take out a strong flashlight and look here very closely at the vegetation that appears grey in the distance, suddenly all these colours and details of complex ecosystems of life bring forth. And for this became a way of using neural networks, trying to recreate not a direct source of the data, but rather trying to recreate an experience of that, which find to be, for us at least personally, quite important and quite a powerful thing.
Now, going back to the issue of the data that we were mentioning earlier, we wanted to revisit this in a different context. And well, I'm not there to hear your answer to this, but if you think about data online, which one do you think is easier to find data about? The red panda or the boreal feather lichen? And well, as you might guess, it's the red panda, right? And that's because they're much easier to engage with because they have a face. And the face, in a way, is kind of the interface for us to understand other species or to even understand, well, our own species, right? And lichen doesn't have a face. in the sense that we expect that we expect it. So we started to think about that, and particularly in the ecological context of creatures being threatened or endangered, and what that means in terms of data that we can get about try and map what percentage of the endangered species is actually represented. And what we found is that it's mainly the species that are cute to us, that have larger conservation efforts around, and that have a lot of Instagram photos, a lot of Twitter tweets, etc. And even when we look on the red list, which is a huge effort aiming to list all like threatened species or the conservation status of species, we find that a lot of creatures actually don't have a photo at all, and they barely even have any information about them. And we wanted to use this kind of, again, this issue of lack of data as a statement for a project. And that's because AI, as I said before, cannot create anything from lack of data. It cannot really imagine what these creatures look like unless it gets an example about them. So, Khalid, would you like to start?
Yeah, so what we did was we tried and found the largest available open data set of species across the whole spectrum, from flora and fauna to fungi, mapping on microorganisms and so on. This is the largest data set out there, 2.7 million images across cataloged into 10,000 species. Now, this might sound like a lot, but as you know, we estimate that to be 8.3 million species out there, and of those, we've only really cataloged about 1.2. So what we did was we trained a then cutting-edge neural network, a transformer model, on this data set, first to be able to create examples of these 10,000 species. Basically taking the best data available to us then, trying to see what could we recreate with that. Then from there, what we did was we built a tree of life with these 10,000 species, the tree of known data as well. So we're performing basically a kind of speculative attempt of thinking about if we are, 50 years into the future where all these species are extinct, based upon the data we have now, what kind of image can we actually get of what we have lost? So we took the tree of life, and from there we mapped these 10,000 species into a sort of rather crude tree. And then we took this red list and tried to map out the nearest neighbors of these critically endangered species within our tree of known data. And the results then become, as you see here, the peacock tarantula, which is a beautiful spider endemic to India, has, due to the knowledge of the model, we get a rather accurate representation, but this generally is more of an exception than a rule. As we hear with the mangrove finch, we start to see that there's quite a bit further of a distance between species of bird that the model knows and the actual species out there. And this continues for quite a while across quite a few different species and life forms. Some are closer, some are further away, but for us this really helps us map out what we know, or what we're able to create from what we know. And at the same time, I think, at least for me personally, from where most of these critically endangered species are, the scientific name and very little other information, it inspires a lot of curiosity as to what do these specimens actually look like.
And yeah, we were very lucky to get to exhibit them in a public art context in Times Square. But this is a very meaningful project to us in the sense that it's a project that's shaped specifically by the lack of something. So yeah, I hope you have enjoyed this, and thank you very much for taking the time to listen to us.
Thank you, Sophia. Very impressive talk. We will slightly move the furniture and we'll move into a panel discussion. So please stay with us for a while.
Sophia, you might, if you could turn your video, maybe might be great. Thank you. We'll try to do it this way.
You see, maybe from the room over you have it projected.
Yeah, I can see.
Yeah, for the panel discussion, we are joined then to Bruno and Michelle Aletti. So, how should we start? Especially the last point, Sophia, what you showed. Maybe it gives a hint for a new kind of thinking and practice. Well, today the first panel was very much about actually methods of design, or like how AI and so on, like for us as architects or designers, change the ways how we design, learn design, and so on. And I thought maybe, or like to talk also, what does it mean for practice, or what are different ways how we can, architect or work with a built environment. And this we don't talk so much intentionally, actually. We talk always so much actually about the ways how we design, but actually what do you want? Like what kind of impact that can have on a built environment. Maybe to mirror your project, this exhibition and symposium did not really happen because we had some ice rain, but what happened in Austin's region was that a lot of trees actually were cranking down and breaking down and simply dying, because over the last few years we had so many droughts and again cold freezes, and simply the trees don't keep anything in our region. So, and then we have faced so many problems with how we build and how we have cities. But then on the other hand, we have all those promising technologies. We can easily talk in those symposiums or conferences about very enlightening ways how we can project to what actually all these ideas lead. And this room, like maybe you see it on the camera, like this overview, we were in a panorama of like a speculative, very positive features. But my question is really like how we can really change our practice or how we apply design, that it's really becoming much more meaningful, much more meaningful. I think that there is in the difference what actually, of course, AI is a long word in itself, but I think that we have a lot of meaningful expressions or like ways how to design this before, but also new understandings, how we perceive the world and so on. And my larger question is like really how we can really put this to work. And maybe like starting with response to Kyle's question, like about do those kind of AI systems devalue the work of an artist, that you can instantly generate images, and it devalues the work of a draftsperson. It devalues the act of drawing, but architecture is always like about the advocacy for all what the building is. Of drawing is maybe like the departure into the new topic of what a practice can be. So I never have really like questions, like more like trying to build an environment, or like starting with, like, I don't know, like maybe like what I think would be really great to discuss. Maybe like could we maybe start with kind of statements where you think like your work could unfold a different way of practice or meaning in a kind of existing built environment.
I think it might be most of the people here. I feel least qualified in a way to address your question. I studied CAD, and it's a disciplinary project of how one works, very internal discipline in a sense. And I feel you pulling me to consider how we can move these ideas, or how these things change the very discipline of this world. And I feel like you're right to ask it. I just feel less prepared to answer it, and without several steps between me and it. But maybe I can try to tie it to.
How about I start?
Okay. Okay, that sounds.
And maybe you are the tool.
Okay. That sounds fun.
So I may also not have full answers, but few provocations. Sometimes when we don't have answers, maybe we can unify things. Sometimes it's good, like rather than, oh, I know this, maybe I know what we shouldn't be doing. And maybe I'll start with that. That ties back to some of the conversation we had earlier in the morning, what Andrew was saying and Jenny was saying, so I will pick up on some of these. When you think a little bit about what happened in the last 15 years, when the new tools came, such as Grasshopper and Rhino, and people were so fascinated with scripting and so on, and I remember that was my time. And majority, I'm not saying all, but the big trend as an average was to generate form. And we spent all these 15 years generating forms that we at the end couldn't even, I'm generalizing it, evaluate. And if we think about this 15 years, if we put all that energy into something else, like, for example, maybe spending all this time on thinking about simulation and putting that energy into learning and making sure that we learning about our forms, doing something more intentional or being useful or being able to evaluate them, maybe that now we will be able to say that we actually did something, I don't know, meaningful in the past 15 years. So this is kind of my take. I always look back and like, what did we get at the end of the day with, with that? And of course there are exceptions to it, because we got some of the softwares that we got out of the Grasshopper and some of the amazing projects and installations that came out as exceptions, but as a kind of big part of what we taught in schools when we explored, I feel like it was a wasted opportunity. So I hope that now with these new tools, we will think about it and maybe instead of using them and using AI, hopefully once it comes in a three-dimensional form, rather than maybe using it to generate just form and creating new formalism, maybe we will call our trend new, and this is coming from Jenny, about intention, new intentionalism, or maybe new conceptualism, or maybe meaningfulness, or some sort of way of thinking about our buildings and architecture being and addressing the catastrophe that happened, just for the past 2 years here, right? Or maybe energy systems, or anything, I would actually say, but just, generating forms that may not necessarily give us much information or anything that we learn. I often look at the images that we see generated from Midjourney, and I actually, as a provocateur, get frustrated because we are maybe our students get these ideas that things can be generated in an instant, and that they can get a lot of great ideas about lack of gravity and things that can spit out immediately, that then again they don't have to put any thought into it. And then again, us faculty will have to now spend a lot of time thinking, teaching them to, discuss this and spend time talking about problems and how we solve problems and so on and so on. But anyway, how do we deal with this problem? How do we steer us toward not thin data or shallow data, but toward meaningful and insightful data, using it toward meaningful and insightful projects? I will really hope toward this, so maybe I will start with let's not go toward new formalism and propose something new. That's as a start.
Can I argue with you?
Yes.
in a good way.
Sure.
Because this is a question I started to raise over lunch, and this is a piece of it. The problem that we deal with is actually inherent to our method. We're a field that is heavily dependent on precedent. We study precedent for multiple things, and the precedents we study, are always defined, as a form, as a formal object, as a material collection, but inherently as an artifactual thing. We don't look at precedents in terms of really understanding behavioral aspects. We might assign those behavioral aspects to the form. So if you were to query, give me an energy efficient building, it will pull up forms and images for you, but not something that would actually deal, with its behavior. So I think that the question that I'm asking is, it is so ingrained in our methods what these precedents are. And this even goes back to Andrew's discussion, sort of looking at the data set and the biases that were in them. That's the precedents that certainly the author, has been using. I think about all the way through, for Sophia, that fact that images, which are the precedents, did not exist for the species that you're looking at. We are always dependent upon its representation, a precedent that has a representation, it has a form, it has an image, and that's what we scour, that's what we collect, that's what we try to sort of learn from. And I think that trying to crack that open so that, we're not continuing, to, I think it was Ed who said it in the morning, we're not continuing, to have the snake eat its tail, because we're replicating those things, repeating things that actually may not be true because we've assigned them to the precedent. How is it that we can begin to challenge it when AI is actually built on history and precedent? And we can even take it to the point, if we think about decolonization, we've had such a narrow reading, for 2,000 years of what we consider to be architecture. Such that if we think about the types of images, the types of data sets that we have, the things that we'll call up, we're also going to see them limited by the very way that we've constructed our own history. So our own history is also sort of narrowing things down. But how do we begin to sort of crack away at this and sort of expose ourselves to those species that don't have pretty cute faces, expose ourselves to these other ways of looking at things, because we can have that opportunity, but not if what we start with is already limited by the very biases that we're also bringing to the table, not just what the authors of these different algorithms are, but our own variables on what we sort of qualify and what we tag.
I think we even have less than even add to what you're saying. I think we even have less than we even imagine, because just to even compare professions, architectural profession versus medical profession versus law profession. Like in medicine, you have MetaLink. In MetaLink, you can search you can cross-reference entire database for medical research. In LexisNexis, you can look through all legal cases of American history. We, as architects, do not have database of architecture. We do not. Our database of knowledge, of architectural knowledge, is disorganized and decentralized. We rely on images. That's the only thing we have. And warehouse, SketchUp warehouse, where at most we can find falling water and, I don't know, Le Corbusier, Picasso, that's it, right? If you look at, let's say, maybe we are lucky to find, like, I don't know, Bilbao, we're going to find a section and one plan out of 6. And we do not have that. So if you want to find a proper data on architecture, there are 2 places you can go to. You have to go to an architectural office where that meaningful data would be sitting on the office server, or you can go to the office building and planning, right, where the drawings were submitted for permit. That's the only 2 places where that data sits. So maybe also one project that could be done with AI would be to collect and organize architecture data first. That would be actually kind of an interesting project, I would suggest. But that's also, besides the biases and the lack of, also problematic history that we have, like, we do not even have correct data that other professions have.
It's so interesting for me to hear you argue this. I think you're right, but we have the built environment as a data source, which is right in front of us. And I think that what's so exciting to me about your work is that it doesn't, unlike other work, it doesn't rely on, like, your data source for your autonomous robots is not, an archive of modernist photographs of modernist buildings or whatever. It's the place that's in front of them. It's the people interacting with them. It's the air currents that mess up the flow of your balloons in a wonderful way, I think. And I think that that's a potential rich data source. It's not a data source of intention, right? It's not architectural intention, it's just what's there. But maybe this is a healthy shift for us. Maybe the precedents are the world around us.
There's a story that Amazon bought Roomba for $1 billion, and I guess it's not because of the Roomba, but actually bought the plants, which I collect. And that's also one thing, that actually these databases exist. Your telephone or Google has for sure. You can, so simply by Wi-Fi signals, you can freeze scan actually the room. So that database is actually the data that exists from the environment. Actually, we don't have access as architects. Or maybe other people are in future architects, the same as Beaux-Arts architects don't teach anymore, but modernist architects or modernist curriculums.
And folks in Silicon Valley played fast with this term disruption, and put a lot of stock in its value without really giving much thought. But I think that we would be wise as a discipline to take advantage of moments of change in anything. Here we're talking about a technology, a representation, basically, that helps us think about things in a different way, to also think about the way in which other parts of the discipline can be changed for the better, to this as an opportunity to rethink, for example, our relationship to clients, our relationship to the environment, the way that we structure the legal aspects of what we do and whatnot. And I think it's an important moment to keep in mind the way that we want things to be. This is an opportunity to make things more the way that we collectively want them to be, to address exactly the kinds of challenges that we're talking about. And so actually for this reason, I was going to say to Sophia that I really appreciated the talk and the example. I think it's a clear, so we're in a room filled with images that were generated by what's becoming a commercially available piece of software for making visualizations of all kinds. We're doing a bunch of architectural visualizations. And I think that what the work that we just saw, the artistic work that we just saw, demonstrates a very different relationship between author and creative work that isn't mediated by the decisions of David Holtz and Midjourney headquarters, where that is, by myself, I guess. But instead is mediated, oh, sorry, you're unable to hear us. I'm giving you lots of compliments, though. It is instead mediated by the intention of the author, the intention of the artists that are behind you on the wall. I think that's really compelling and inspiring, and I hope that it's something that we can emulate in the way that they dig down deep into these technologies and kind of claim them for their own voice. Yeah. Sorry.
Sophia, maybe the comment or question about your work was the development of the data, basically what you call the development of the data set that didn't have any reference other than the tree of life. Maybe you could, that's a very simplified version of what you asked. But perhaps that's a good jumping off point. I actually found it fascinating that we started with a lot of references to the Cambrian explosion this morning, and then we ended with Sophia's work that sort of tries to reconstitute the tree of life and the loss or the lack that's sort of proliferated in sort of Anthropocene. So, but maybe you could talk about that aspect of the work.
Yeah, for sure. So also relating to what was happening previously, that I only heard a few snippets, but I thought it was interesting to ask or to think about. Something that AI has kind of shown me from working with it is that it's really important to not just look at the potential, but at the limitations of it as well. And the reason for that is because we can only be creative with it when we're thinking about the limitations. That's at least, like, I'm not saying we can only be creative in that way, but I think it's really important to think, what am I missing here? And very often, the main issue is that we can only use data from something that exists or from something that has been captured in some form, and that is missing an aspect of reality, because reality isn't discrete, isn't something that we can always plan for directly. So that's something that I find really inspiring to think about these limitations. What is being lost right now? What is missing? So yeah, particularly with the natural world, I feel like that is really important in terms of representation. And something that I like to say about my work as well is that I know it is extremely biased. I know that the pieces that I'm working with or that I'm selecting, like maybe one out of hundreds of outputs, I know that that's something that I deem at a particular moment aesthetically pleasing. So I cannot, even were I to create the most unbiased data set in the world, something I haven't done clearly, but still, even if I were to do that, there is the element of introducing my own bias to it. So yeah, I don't know if what I'm saying kind of helps answer the question in any way, but just a few comments on that. I very often get asked if artists will become obsolete completely, and I find it very hard to answer that question, because I think that art has always been in motion, and it has always been changing. It hasn't been like one static thing where we started making art just because we had one paintbrush. it has taken a lot of different shapes throughout time, and it's important to remember that tools will come and go. Maybe right now we have AI to make art, and some of us will use it for that. Some of us will use it for architecture as well, but it doesn't mean that it will be the only tool that will be used from now on till the end of times. Yeah.
I think, that makes a lot of sense, and to me, maybe it's a good way to start to link the talks together, because I think one thing that I thought after listening to them and trying to make sense of them as a group rather than as individuated elements is that one sort of through line between all of the talks is this sort of linkage between work, the evolutionary sort of trajectory of AI of the work, or Sophia's sort of invention of a lineage of elements in order to make new ecologies. And I think, it's evolution of the field. So it's the very first sort of nascent emergence of something crawling out of the ocean that becomes something later, not to get too much biological about it. I was inspired by Sophia. But I think, if we could start to think about like the sort of the interjection of error, mistake, new people coming into the field, people that are operating outside of sort of paradigms or hierarchies, like to me that's a much more of a natural evolutionary kind of like milieu to operate within, and maybe you could kind of reframe or respond to that.
Can I pull back to
sure.
To Sophia's comment? I'm sorry. I'm having trouble wrapping my head around what it would mean. I'm taken aback by the use of the word bias, and thinking in particular in this project that you showed, like the jellyfish, right? So the data set is images of jellyfish. What does it mean that is biased? Like I think that, I really love the word. It seems to me it's out like a model that was made specific by an individual artist for a specific purpose of making jellyfish images, and it contains a bunch of jellyfish. It seems like the issue of bias is just besides the point. Like it's your subjective decisions about what's in the database and what's not is exactly what I'm looking for. I want your subjectivity there. And to me, the idea of bias. There's feedback here, Sophia. We're all covering our ears now. The idea of bias is only relevant for a system that we expect to be objective in some way, like Midjourney, right? We want to be able to make different images out of it, right? We want to assert our own subjectivity there, right? But with your work, I feel like it's beyond the bias. It cannot be biased or unbiased. I don't know. What do you think?
I think that, so once I got asked, how can you use AI, which is a tool for oppression and bias, and try to speak about ecology and representation with it. And I thought it was an interesting question in that I think that a tool can be used and misused in a lot of different ways. And first of all, it's important to say like the whole purpose of art is to be biased. The whole purpose of why we look at art is to look at someone else's experience and maybe reflect on that. And it is really important to think that what it means in that context, in the context that it is presented. And something, I follow the work from an artist called Alex Revin, and something that I really like about his work, and maybe this is stepping into a little bit of a different direction, but he works on creating robots, and he has this piece where basically there's this artwork that's being consumed by robots. So it's like the idea of automating consumption of an artwork. And to me, this brings me back to thinking about this thing of art or artists or drawing artistic processing is becoming obsolete because of AI. We cannot automate everything yet to the point of extreme automation. There has to be, a kind of element that we still have to do ourselves for it to be to continue evolving. Because otherwise, it wouldn't make sense to just really automate everything for the sake of automating. I hope that makes sense to your question. Maybe I didn't answer enough about bias.
I think it does, and I'm also a fan of Alex's work. He did that piece recently in London where the curation of the paintings, I believe, were automated. And people were making paintings at the direction of an AI curator who was giving direction.
Sorry, this question you mentioned a question about evolution. Sorry. Go back to that.
I was just trying to make some connections between all of the work. I mean, Kyle started by talking about adaptive reasoning and that sort of linkage, and I felt like that was a through thread, and the sort of breakdown of the recent evolution, well, the whole evolution of AI from mid-century to now. I thought started to talk about like this developmental trajectory of work that works in fits and starts, it works in jumps and leaps, and it works with threads that end up nowhere and things that kind of find their way through. And I think that sort of process and then Sophia's work does the same thing. And I feel like when you're working, it's working in a similar kind of context. So I was just trying to maybe ask the question that links things together. You might not see it as evolutionary, it's prototype development, but it seems to me as it operates in a similar vein. Like it takes an abductive logic to make a floating
Well, no, it's
right?
totally, no, I think in my work, it's definitely evolutionary. We work a lot in prototyping, and the process always from studying the problem to testing, doing the first kind of proof of concept, testing with users, failure, yes, no, killing the project, yes or no, and then the decision to move forward, prototype number 2, and the cycle keeps completing until you go toward hopefully productization, but in that process the projects are being killed like a lot. So to have a successful project, I would say, I don't know, maybe 1 in 10 really makes it. So it's not just evolution, but it's it's a lot of things. They die in a way because they don't meet certain criteria. So like the balloons, they didn't even make it past the first proof of concept.
Isn't that not great that you can 10 100 times faster? Wouldn't that not mean that we get a completely different level of research? Or, like, can we really see that what's happened like beyond like drawings, or like would it really accelerate research? Or has indications of really how we build, how we come to that point?
I keep thinking about it, and the only problem is that the physical world is difficult. Software is one thing, and software is also difficult. I'm not saying it is, but when you think about the physical space, it's incredibly difficult. It's the problem is just on like a tangential, accelerated difficulty chart. So you may always, with software, you can continue developing software until like the day of a product release. But with doing anything physical, you have to always have a moment of like pencils down, because now you have to send it to the fabricator, or now you have to go and fabricate it yourself, or there's moments in this process that you can't go until the day before you hand in your product, because unfortunately it's our physical limitations, right? The objects or spaces and architecture has the material properties, structures, sometimes they have mechanical parts, electronic parts, and so on. So I always think about this problem, that with software, in a way the problem, this digital space of AI is somehow easier, even though it is difficult, right? But it's software. But the physical space is just so much more difficult. So I don't know when we're going to overcome that and how.
But if you're not working on that.
But I see, sorry, just one more thought. But I see if we don't solve it, and we as architects, I know who is going to solve it because they're solving it. It's going to be the construction industry. And if we don't solve it here, the construction industry is already using, so much of automation that AI is going to come in because they're using it for fabrication. So we will be forced to use their tools. We are going to invent something. This is how I see it. But our space, physical space, it's very hard. So anyway.
I think this is what I'm with you, and I think this is a wise approach. We're not tying all the talks together. We're making a distinction. Software and the physical world. I think this is actually really smart. So this new technology that's around us is a way of directing systems tacitly rather than explicitly, right? So instead of writing code that tells the computer how to play the chess or whatever, it learns through example and through massive amounts of data. In the built environment, or in our world, let's say, this to me has two clear but very distinct applications. And one of them has to do with imagining a radically more responsive built environment, which means I've got to program the built environment the way I would program a computer. It's better to be able to program that in a tacit way, as Jenny showed us, as you showed us, than in an explicit way, because it can be more responsive to the complexities of life, the complexities of the world, right? They don't have to account for every situation in my code. I train the thing like a child. Train children. No. Sorry. My children are not trained at all. You know how to do that. You train the thing, right? I don't know. It's trainable. And that's a very different set of applications. And I agree, harder than, and this is what I was kind of insinuating at the beginning, when I was like, I don't know, than working in software or working in representation, right? Which is where my head goes when we saw it in Andrews. It's a form of it's an intervention in the design process. And God knows we need more tacit systems to support tacit thinking in the creative process. And I think this is more the kind of creative, the world of art. I think it makes a lot of sense to talk about it in this way. But this is a distinction, right? So the future College of Architecture, these will be two different departments, right? And they both will benefit from generative statistics, but they're different skill sets and they're different applications. There's different issues involved.
But
let's make it be college.
Yeah. Well, maybe it would. Yes, go ahead.
In difference to virtual or classic digital architecture, does this or the image generated output, does it look physical and feasible? Really?
You mean like these things
like
physical?
Look they in general like physical and feasible? Or do they add, or to your opinion?
This one. No.
That was really nice.
I think it's just like all of this.
We know that from research on language models that the larger newer models, they begin to deduct or draw causalities in physical space. So they know what breaks when I let a bowling ball fall on the ground. They know that the ground and the tiles will break. If I let the violin fall on the ground, the violin breaks. So it knows the difference between physicalities as a physical begins to understand. So I think if we move more and more and move forward with those models, we will move also in this is a good question. Where is the limit of a digital twin, of a representation in a digital space? But it doesn't have to be absolute, but it helps, I think, tremendously accelerates what you can handle in complexities. And when we talk about more ecological, more symbiotic understanding about space, then I think that this goes very much in that direction.
Yeah, I think maybe we can, I think ultimately the architectural imaginary is an important step in the next phase of things. So we can take some questions from the audience. If anyone has any. Yes?
Great discussion. I just was thinking what the panelists think about what does it mean to do research in architecture? Because I think that I agree that maybe there aren't the amount of need from the past in order to kind of make decisions today about certain things that are urgent. But maybe that has to do with the way that research is sort of envisioned in the studio or academia, at least architectural academia. So I'm wondering what's your ideas about research.
I'm going to include some of that in my closing comments. So,
I will start with a slogan. Follow the slogan. Yes. Every student should have a research component. Is that a good slogan? To start with, I mean, how can you start any work without research? Right? It's super important, but every problem is different. Whether you, like in our case, when we're starting looking into mobility and different type of mobility systems, we weren't looking at precedents in architecture because there is very few. So for us, it was machine. So that's where we were looking into. We were looking into the behavior of machines and the technology itself, and looking from that perspective of how that would impact the space itself. So it's a very different type of research than maybe looking into a precedent, architectural precedent, and taking that into your studio. So I think you have to make sure that your research matches the problem that you're dealing with. You can't just always apply the historical precedent into the problem you're dealing with.
Yeah, I mean, the only reason I ask is because we always talk about being interdisciplinary, and if we work, let's say, with other disciplines, they have a strict research way of doing things, and sometimes as architects, we don't understand or at least know programs to do them. So I'm wondering, that's why I was asking.
Yeah, I mean, you look across the university, and like what research means in humanities is different than social sciences, is different than quote-unquote hard sciences, is different than music, and architecture's got all of them. So we're confused.
Well, I think it seems like one interesting part of that is I mean, you sort of talk about problem-solving approach, which requires a certain kind of research, where you have the problem-seeking approach that you kind of talked about in your talk, Kyle, and that those are maybe parallel or twined together in some ways when architecture is done really well. But I think maybe it's sort of like pulled apart. We're starting to pull it apart again so that you can look at them independently and then start to twine them back together.
I mean, like a research buyout, well, architecture has a very own method also, of course, like simply designing, composing. So I think there's something inherently different than just designing with words or like composing something with words. And basically do something in space. So we have our methods to really grasp very complex content. But then, of course, there's also an aim for research, and it's like at the moment, we live in the future, so I think it's very clear when most like want to project. And I think what we saw with digital architecture over the last 20 years, or Acadia, how you invent the tools, how you prototype in a way, like new kind of materials and so on, which could be applied. And I think we go in a much more practical direction, more complex, more larger scales, and we can actually grasp a more direct implicit this can be. And I think it's very crucial.
Yeah, I have a question. It came up a couple times today where I was just reminded things that just disappeared on the screen over there, but Daniel Bolajan, that he did a lot of early research, and Kyle, you showed some about training models specifically on a certain body of work, and that they performed very well in some ways, but only when you asked them to do kind of exactly what they were trained on. Right? So then there's what happened in the last couple of years. They talked about these large language models or foundation models, and what's great about them is their ability to combine kind of novel, or they're able to combine ideas in novel ways. The problem, though, is that they seem, because they're trained on scraped images and data off the internet, they specifically, I'd say for architecture, they seem kind of shallow. So we have these two models. One that's like very, very specific, but limited to Zaha Hadid's work or whatever it might be. You know, like these highly specific models trained on a few hundred images, or these gigantic models trained on billions of images. So, like, does it make sense to create more domain-specific models? So, like a foundation architecture model, and if that makes sense, who creates it? What's like a framework for creating it, so that we don't, have, let's say, our current biases of, and how do we create a model that would still be open to? And one last thing is, it seems like I'm not even sure if architects are the best people to make it, or is it like you're saying, like historians or people who are really good at language? You know what I mean?
Well, I mean, if the world is as it is right now, you know who's going to make that, right? It's Autodesk who's going to make that. And they have access to a great deal of data, because anytime the BIM model gets run in their cloud, they can use that for their training sets. I'm 100% sure they're working on something like that. And of course, that would be a shame for all the reasons that you can imagine. It would be a shame. So I think that that's a better way to. I mean, I want new social structures to reimagine that are different than what we have right now. So it's not commercial forces in the world of Autodesk that are going to put that towards their purposes, but instead some other more inclusive, more enlightened constituency. I hope that that's the case. I think another question in that question is, what's the right mode of representation for such a model? Because there's nothing saying that like images are the best way to describe architecture, right? We know that quite well. There's a myriad of ways of describing architecture, each of which asks its own set of questions and allows its own set of or speculations of what the building could be. Are they plans? Are they network diagrams of room relationships? Are they thermodynamic models? What's the right, or are they combinations of these things? I think it makes the problem much harder, of course, because we've got this technology already, so that we get further out. But I think it would be well served as a discipline to find a way to think through that together and collectively do something. I'm on board.
So, architectural representations, like before those image synthesizers, how many drawings had actually trees inside of people? And now, like, how many images don't have trees? So I think when you have the larger models, that means also you always you drag something into your own design, which you didn't thought about that, but what, of course, everyone desires. So like the data, or like just arbitrary images from anyone, that's actually what people actually also desire. And for myself, like as an architect, I completely enjoy this, of course, and somehow I can't blend this out anymore.
Just to be clear, though, I didn't mean that we should replace the foundation model. It's more like there's a base level foundation and all knowledge, straight from the internet. And then there's like maybe not just one secondary foundation model. It's called a floor model. That there's like architecture, but then there might be architectural plan model, architectural section model, or architectural the thermodynamic model, material model. That could build on top of that, so that we could still have these kind of relationships that we get from the large foundation model.
more control, basically.
More control, more specificity, less control, more collectivity.
Yeah.
Right? And those models draw causalities, like about data which is not there. So with language models, what shows that they learn actually begin to understand languages which are actually not well represented in the data set. So maybe this can also happen with more that you add to those models. Or now that you I think we should call another question from the audience.
What exactly is being looked at in new foundation models? Can you hear me?
Yes.
Hey, I just wanted to follow up on what Andrew and Kyle were just discussing, and especially in the context of Sophia's work. Sophia, one thing that occurred to me is if you look at typology from a genetic point of view, or an epigenetic or a holobiontic point of view, then build your foundation model to create the hybrid creatures that you're creating, you may end up with a physical morphology that's very similar to the ones that you're getting, but you'll arrive at it through a completely different kind of foundational principle. And it seems to me that from an architect's perspective, we can take a similar approach. There's the kind of morphological variations being endless comment that Chumi made years ago, or there's an approach to architecture through, let's say, heat management, the way that Fernandez Galeano takes it up in his book Fire and Memory. And he specifically cites that against Michel Serres' work and Margolef and Stenger's work to try to understand how architects after centuries managed energy. And then he spends a lot of time in that book looking at typologies of like furnaces and HVAC systems. And it's kind of a weird book in that sense, because you would expect a utopian or a radical conclusion at the end of it, something like, and this will be the architecture that frees us all, almost like a Constant-like approach or something. But no, it's like a catalog of heat management systems. And to me, there's another book to be written after Fernandez Galeano's book, which would be exactly the foundation models that you were just talking about, except instead of looking at fireplaces and furnaces and heat management systems, you'd actually look at some other form of value that's gained by managing heat. And he points at that because he talks about, the hut in the forest, and whether you burn the wood in the forest or you build a hut in the forest. And, he tries to constitute a non-architectural act as an architectural act. But to me, it seems that that's precisely the value system, Andrew, that you'd be looking for in building another foundational model as an architect. You wouldn't want to just have 2 million architectural plans and sections, and then be able to generate, architectural plans and sections that you could immediately start working on in a BIM system. You'd actually want to have some knowledge about the value that was gained by some of those architectural plans and sections. And I do feel like Marta's project started to take that up a bit, in the sense that we looked at optimization of movement. But then, there would have to be this really designer-oriented kind of radical step there, where you would say, hey, look, that movement in the kitchen just isn't good. And in a very funny way, it's a retrograde movement for us as architects, because we rewind to the 1950s and we imagine how many movements does a housewife have to make in the kitchen when making a cake? And let's optimize the scale of the countertop and the distance to the sink to make sure that that optimization is achieved. And I'm pretty sure that everybody's hackles immediately were raised when I just described that model, as are mine, because it's outrageous. But at the same time, that need for optimization, I think, is what we're constantly facing when we look at the foundation model construction, and what kind of ontology is the foundation model, and then what we think we're actually extracting out of it. And so Sophia, I thought in your work there was something really fascinating in the sense that it would almost be like looking at these creatures as you do, and saying, okay, but what we really want to do is we want to engineer a new form of reproduction that somehow is free from the demands of predator-prey relationships, or free from the demands of gender relationships, or free from the demands of, need to, you see what I'm getting at. And then build a foundation model around that thought experiment, and then see what kind of formal typologies emerge in the bodies of the creatures, or what formal typologies emerge in the kind of, external phenotype of the architecture. And then it seems to me that kind of thought experiment would be really quite beautiful. And I can easily see, I I can see, Andrew, that some of the process, the rigorous process that you described earlier in your presentation this morning, being run through with something like that, driving it up front so that you're always seeking a kind of a novel emergence of value systems. But in any case, I feel like this is a really, really important point. And Sophia, maybe you can speak to this a bit. Foundation models that are built on phenotypes of buildings, in my opinion, miss a vast percentage of what happens in buildings. And so somehow we have to be looking, and again, maybe I'm a child of Chewy in this way, we have to be looking for an almost ineffable event structure that constitutes the ground for the foundation model, which then leads to typological and phenotypical innovation, at least in the sense that we're talking about foundation models right now, because they seem like they're building the shell and not the pumping heart of the system.
Yeah, absolutely. That would be an amazing exploration. What I can say from my side is the way that I started making these was I didn't even start thinking about artificial life forms using AI. I first started doing 3D renderings, and then when I discovered AI, I thought, wow, there's so many possibilities here. And I think like when I first started, I didn't have a clear goal of what I wanted to achieve. But with time, I started to kind of structure my process more. I think, well, so partly with speculative life, there's a lot of things to consider. Partly why we're interested in kind of speculative biology is because biology is something that is a human construct, right? It's something that we have built to understand and make sense and structure the natural world. But in reality, we don't really have those limitations. And partly, one of the things that we were fascinated in looking at is like, what would a speculative biology look like, and what would it say about us looking at the natural world? And so a lot of our approach is more based on how we relate to the natural and how we create this dichotomy between nature and technology, and how one implies or they're kind of like opposite things to each other. So yeah, I don't have, unfortunately, I've never worked on a project precisely like what you described. I wish I had. But yeah, no.
Thank you, Sylvia.
And this picks up on the question about research. Kyle, you mentioned that we have a built environment model in terms of certain data sets. But the issue at hand that is, I think it's come up a number of times is access, whether we have access as architects to those data or not. And that also then presents this sort of scenario of the open source and libertarian ethos of collaboration versus the closed model, and conducting advanced research in that paradigm. I'm sure there are things that you did not show us. I think there are certain things that I did not show for obvious reasons. And I think there's just so much potential for us as architects to engage in design processes with these dynamic behavioral data sets that tell us more about our environments, more about ourselves. But until we crack this problem of access and really begin to translate these new value systems around data, we're sort of caught in this difficult paradigm. And so in terms of the question around research, like what models for research are we finding that are productive? And maybe it needs to be a form of inserting ourselves in these spaces to sort of push boundaries. And I think the relevance of design and what we bring to the table is being recognized across multiple disciplines. The NSF just recently announced last year the 7th directorate around technology, innovation, and partnerships. I think there's huge potential for us as architects to have a seat at the table. But I agree with you, Martha, that there's a risk if we don't actively engage, we may not.
I feel like you're probably a better respondent to that than I am. Totally agree with you. But I just wanted to clarify, I didn't mean that we have the built environment model, and I meant that the built environment itself is a source of information with sensing. Okay. So.
No, I totally agree. I mean, there is, yes, on one hand, we have access to, right now, this, let's say, Journey or some of the software, but this is, I guess, also part of the boom in the last 15 years is also ability to get access to GitHub or some of the code, right? So people who maybe are not software engineers can, spend time in the basement and figure things out on their own and crack the code and learn certain things. And all of a sudden, also some of the software, that is, one is access, and the second thing is ability to learn on your own, because literacy level and softwares are just getting easier and easier to learn. That's another thing. Like I remember, 2 years ago, doing a CNC required only 3 days to spend setting up the machine, and now you just spend 5 minutes, right? So these are, I think, two things. It's access and this ease of use. But when you start thinking that who has the data, who has access to that data, like Roomba, the fact that they have all this data of all our apartments, I mean, that's kind of crazy, and they wanted to sell it. It's huge, right? And these are the micro data of what we could have and what we could own. It's just now the question of how do you get there, right? How do you create this kind of a source of activism? How do you push the boundary, and how much you can start to, show of the projects. Like the project I showed, I mean, these are very few, 30 probably that, I worked on, and the projects went on so much forward than what I could show. And there is a tremendous amount of data and power behind, even the lab, because they have the money and so on to develop research and information and have the money to build all the things and have experts to work on these projects. And, just only this much, that 5 images that are out there that you can show and are, to be part of the public to discuss. So definitely a difficult problem, but maybe one of the ways to engage is through partnerships. So that's what you're saying, and I think that's one way where I was able to teach one of the seminars together. So that all of a sudden, that seminar's work is already public, and that the balloon project is already public. The students are part of it, they get the exposure, the work that comes out of it. It's already part of, the public realm. So that's also one of the ways that maybe some of the cracks can happen. So I like that also, the idea of what you're saying, maybe grants that would be interesting. Kind of the partnerships and so on.
So one quick point. I really liked your project, the chair, where it's predicting the behavior of the person and understanding the kind of rules of their own habitation. Reminds me of Sophie Colley's project that they're following. I don't know if you know this one, where she followed someone for weeks, took their habits down, and then did what they were going to do right before then. So they became a stalker. And the whole project was about surveillance, it was situationist, but But we've now lived that, like, Facebook's predicting our habits, our behaviors. And so maybe the question is, what are we predicting? For what purpose are we predicting these things? And maybe there's a brighter future there.
All right. I have a few closing comments that involve a concern or a warning or an admonishment, and then end with hope and a prompt on this. But first, thanks to so many of you, Corey, Clay, Daniel, for organizing this amazing symposium and exhibition so quickly. But not only that, I don't think I have enjoyed myself more and been more provoked and been more excited than I have today in a very long time. So this was just fabulous. For our visitors who came, you all were effing amazing. All of you, I'm so inspired by your work. I also want to shout out to Rasa and to Ria, who had an involvement as well in this and in the exhibition. I love the fact that so many of our faculty are in this exhibition, but so many people from around the world are in this absolutely spectacular exhibition. So hopefully I can be very quick on this. Usually what always happens, particularly when you ask a dean to do these things, they have to make part of it about themselves. So I'm going to make the beginning part about this, about myself, but then hopefully be able to move from there. I am a product of two different digital turns, significant digital turns. I was a young engineer working at NASA when finally computers were faster than what we were working on the slide rule. My first year there, I did all my calculations on a slide rule and with a mechanical calculator, which used linkages to do square roots. It's actually fabulous. It's a free and mechanical calculator. Anyone find one on eBay, I will buy it. But you know, the thing that was amazing about that is that what we were able to do when we were finally had both the algorithms and sort of major mainframe computers that were faster than our hand calculations changed the world. You know, we were able to develop computational fluid dynamics kind of later. We did the first finite element analysis programs. What we were able to launch, how quickly we were able to make things, how quickly we were able to experiment was stunning. It truly was revolutionary. When I later went for the lower pay of being an architect, more than a decade later, we were drafting, we were using name lines, and then the first software came out for us in dealing with computer-aided design or drafting. Back then it was actually called computer-aided drafting. And it was of two ilks, it was two types. There was a type, I think ArchiCAD was one of the first, FormZ, others like that. And then the other type, which were based on, that type was based on, of course, as we know, geometric modeling, orthographic projection, in a Cartesian space. But the other type, MicroStation, was vector-based. So it was in a completely different kind of space, in a completely different way of thinking as you modeled through that. I was a MicroStation fan. I loved working on a Lagrangian problem in vector space. To me, it was a radically different approach, as radically different as I had experienced the decade before, or more than a decade before, when we went from the slide rule to a mainframe. It was a completely different way about having to think about architecture that was not so constrained by the geometry of a fairly normative representation. I mean, the history we all know, AutoCAD emerged and then became the juggernaut with one of the most brilliant marketing moves, I think, in any kind of product history. And, MicroStation vector approaches ended up in the physics world and no longer in the architecture world. The problem with that is that we went for the approach that was most comfortable. It was truly an automation at the time of the way that we drafted. And so the system that allowed us to experiment didn't happen. The system that was most familiar to us was the system that did happen. And even later, as we expanded, we went toward Revit, we still sort of like took all the things that came from different types of algorithms, and we wanted to make them fit into what we were comfortable with. We made them fit into a system that simply was a continuation of the past. So for me, there was two different digital terms. One that truly was revolutionary, another one that was automation throughout that. And so this is my admonishment or my concern, as we look at what the possibilities are of AI. I don't want us necessarily looking at it through the lens of how do I make it do what I already do, just better. How do I make it sort of like just give me an expanded array of images, sort of an expanded array of images or expanded array of forms, but still let me make a building out of it. Still let me sort of like plug in my different types of simulation packages and things like that so I can make a building out of it. Let that go. Let it go and instead allow this thing to ask questions that you've never been able to ask before. Allow it to sort of like take you down paths that we've never gone down. There will be pieces of this that we will want to incorporate, that we will want to build on, that we will bring into the way that we build and we design. But if we start now clipping away at it, and I don't want to use the word clip, if we start now, trying to sort of box it in, like, how do we make sure that we don't devalue, the field of design? We don't want it to do that. We don't want it to sort of like create competition for what it is we do. Let those questions sort of, they can sit on the side and they can bother you at night, but don't let them keep us from pushing us even further, being even more experimental, testing even more things, giving ourselves, instead of, if we think about parametric modeling and the ability to do versions, instead we're now looking at, rather than versions, we're looking at an ever-expanded array of new questions, an ever-expanded sort of like array of different frames through which we can examine different ways of thinking and different ways of different questions that we want to bring forward in this, different contexts that we want to sort of slice things through. This can be revolutionary. I come back to your opening statement where you said, this should be. You actually said it is. I'm not on the "with is" part yet. I'm on the it should be one of the most revolutionary things that could happen to us in architecture. It does require that we go ahead and embrace it, go ahead and take it as far as we can take it, and let somebody else worry about limiting it. So that's my closing on that. But anyway, fabulous work by everybody. It was a thrill to be here today. I'm going to miss you all so much, most of you. Some conversations. This was a fabulous set of conversations today. And gosh, I hope they continue. Anyway.
Thank you, Sophia. That was fantastic. Thank you. We'll be in touch about other things, but we missed you here, but thank you for joining us. Wonderful. We'll talk soon. Bye-bye.